Okay. Mic check. Okay, yep. Microphone's working now. That's good.
Sweet. Okay, good. Okay.
There's a very dodgy connection on the microphone. So, what's going on? We got some viewers, right? So,
Okay.
whilst the viewers build up, what we're going to do is... So, the screwdriver, what we're going to do is, we're just going to take all the screws out from the board. So you see there's like tons of screws in here. So we're going to take, just undo, move that out, just undo all these screws on the board first.
Okay.
You can get it out of the case first and start working on it.
Okay.
Hello from Texas, USA. What's going on, buddy? Sniper King, whereabouts are you from? Black Ops David, whereabouts are you from, man? What's up? Good evening. So it's Monday night, so I thought this would be a fun kind of Monday night, Monday evening, afternoon live stream where we have some fun and see if we can get something working. Washington, USA. Wow, wicked, man. What time is it in Washington, USA at the moment? It must be about, so if it's 9:30 here, it must be, I'd say like 5:30, 6:30 in the afternoon, perhaps? Trinidad and Tobago. Yeah. Yeah. Pretty cool.
Okay. Oh. Already gonna. Right, we put those there so we don't lose them.
We'll put all the screws to one side.
Yeah.
Then when you're undoing the screws, if you form like a little circle with your hand like this to keep it in place, and you can literally spin it like this.
So it's super quick.
Get it undone really quick, yeah, like that. Or you can even just hold it there and just kind of spin it like that.
You did it so quickly. Okay.
Hello from Jackson, Tennessee. It's 1:33 PM.
Oh my
Holy
gosh.
shit! That's early as fuck. That's crazy. I always forget all how crazy the time difference is. Trini Thing says, "Love your videos, great job." Cheers, buddy. Well, hopefully this will be a very fun video.
Let's hope I don't muck up too much for everyone.
No, that's all good. Okay. Evening to Connor. Evening to SDB Designs. Nevis in the building. Yeah, boy, I've seen you on my channel quite a few times. DJ Fizzy Dizzy, how's it going? Good evening. Or good afternoon, as it may be, because the time difference is flipping crazy at the moment. Crazy time difference. So this video should be called British Girl Fixes Car Amplifier, but I can't remember if
No, it should be like attempts to.
Oh no, that's right. British Girl Tries Fixing Car Amplifier. Here we go. Yeah.
I love how you put tries. It's so true. It's so true.
Well, this is a try. And
it is a try.
Be a successful try.
I mean, yeah.
It will be a successful
it's a something. As she says, trying to even unscrew something. So I mean, how bad can it go, right?
Oh, exactly. That's gonna be fine. So at the moment we're just taking the amplifier apart as the first thing we do whilst we build up some viewers, and then we're going to attempt to repair on this. Now this amplifier this is a generic Korean Xenon board. This is a 4.5K. It's actually quite well rated. It does a bit more than rated power. Probably, so you see there's that slide. Yeah. Give you a bit more. Does more than rated power, this board, but this one has a blown power supply and a blown output section, so we're doing a full rebuild on this pretty much. Hopefully the drive circuit isn't too bad because that will cause some issues, so hopefully it's just power supply FETs and output FETs, and yeah, we should be good to go. Is that one causing you some trouble? Is that done up really tightly? Let's have a look at that one.
Those two are like super tight.
Okay, let's have a look.
You can do it super easily now.
There we go, that's that one.
Okay, and this one.
That's a bit of a bitch. And what's the other one?
Just this one. This one. What are you doing different? Are you just like putting pressure on first?
Yes.
Yeah.
I'm too sure. Tweezers. Oops.
Ooh.
Okay, so yeah, that's that. I got one over here. The 666 button. Nah, this is not a date. This is just something very funny. I thought we would do.
Yeah.
It's a bit of a different video. Thought it could be quite funny. Okay, so we've got a couple of screws up here. Just gonna do quick. Take the sides off, and then the board should come straight out.
Okay. Do you need me to collect those little?
Yeah, you got them. Before I make an inappropriate comment, how old is she? Oh, that's not the sort of question you ask a lady. That's not the sort of question you ask a lady.
The name is old. Yeah, age is old.
Well,
Like the same age. We're the same age.
Yeah. So
Yeah.
Myself and my friend here are the exact same age. So I'll let you work that one out for yourself.
Guess Sam's age. This is the next thing.
I'm pretty sure I've declared my age on live stream many times. But it'd be interesting if anyone can remember how old I am.
That would be cool.
So can anybody remember who's been on live stream before how old I am? Let's put the okay, so that should technically now come out of the case. Okay. There we go.
Beautiful.
So I'm just going to put that down to one side.
That came out.
That came out, that's fine.
Okay.
Shove it down there. Move the case. Okay, so here's our board that we're working on today. Okay.
Hey. Doesn't look complicated at all.
Nah, this is simple. This is the easy stuff.
Sure. Okay.
This is the easy stuff. Tron, is that your girlfriend? No, no. This is a very good friend of mine, and we are. So, Adam Francis. Hi, Adam. How's it going, my friend? I think you're the same age as me, 26, 27. Yeah. Yes. Adam hit the nail on the head. That's pretty much spot on.
Well done, Adam.
Yeah.
Good memory as well from Adam there. Did you remember your age? That's dedication.
Adam's part of the Team Waffle guys. Yeah, he's a good friend of mine. So it should be okay. Cool. Right. So here we have a very fucked amplifier on the bench today. LW audio, generic Korean Zen board. Power supply and output section seem to be dead, but Ashley doesn't know this yet. So
I don't know anything, guys.
So here we're teaching Ashley how to repair amplifiers, whether she cares or not is a different matter. This could just be part of fun video. So the amplifier here, all the things that actually do the power, all the things that are actually doing, converting the power, making the sound, the things that are gonna die, are all these things that are hanging off the edge. Okay, so the things that are gonna be the most likely thing that die, and they're always the first things that die, are all this shit on the edge.
Okay, so this is the first port of call when you do something, you're like, right, let's
so if you think of like, think of three men, okay, and
like a joke's coming up here. There are three men in a bar,
and they're all sort of like getting bigger in size. So you got one really weedy little man. Right, but he then has to pass the job onto the medium man. The medium man then has to pass the job onto a really big, strong man. Okay? And so if a really big, strong man is the one that's doing most of the work. So if anything is going to go wrong, then the big, strong man, he's the one that's doing the final bit of the strong work. So these are all the big, strong men. These are the things that actually do the work. So if anything is going to die, it's going to be these. And these are called MOSFETs. Muscular MOSFETs, yeah, absolutely. Let's see what's going on in the live chat. Lee Audio makes me feel old, you know? The 666 bud. I'm almost 40. No way, I wouldn't have said that. Sam, you can say anything. Call the Transformers schlongs. Okay, so these are the schlongs,
so true.
And these are the chodes over here.
The worrying thing is, I'll go up to people like, yeah, I know how to fix amps. Have you heard of the schlongs?
Yeah. Oh, you need to replace the chode driver.
The chode
driver, and
yeah, people are going to judge me. So let's okay.
Oh yeah, the wank stain transformer is bad. Yeah.
You got problems with your wank thing? Okay,
so in order to figure out which of these strong men things are dead, we use this. So this is our multimeter. So this is basically just a tester that has like hundreds of functions. So on the front of our tester, we've got a big dial, and depending on where you turn the handle to, the pointer to, you're testing different things. So when we're testing the MOSFETs to see if they're dead, we're putting them on this setting, which looks like a little Wi-Fi symbol here, which is called diode setting. And when you touch the two wires together, it will make a beep sound, like that. So basically, when the beep sound means that there's a short circuit. So it means that it's basically just a complete circuit with no resistance in between it or anything like that. Now these should have resistance. They should have something stopping the electricity sort of passing through, making a direct connection. So if they're dead, usually they short. So usually they make a complete connection, which means they're dead. So if you take the two probes there, these have 3 legs. Now if you put the probes on between any 2 of those legs, either the outer 2 or 2 of the inner ones, so one probe on one leg and one probe on the other leg, and if it makes a beep sound, then it's probably dead. So there we go. So that one there, that's showing 50 ohms on the screen there. If you put it on there again, so that's quite a low resistance. Okay, so that one that one's basically just dead.
Okay.
So what you can do is you can go along all of the ones along here and test them and see which ones are dead. So that's a bank that seems to be okay. So we've got 5 there. So we've got that one's dead.
That's fine.
That one seems to be okay. That one's dead. That one's dead. Okay.
Okay, so a lot of these are.
Now these ones are slightly different. These ones are actually rectifier diodes, but they look very similar to all the rest of them. The only way you know they're different is because on the board there's a little code next to them.
Yeah.
And this says D and then a number like D20. All the ones that are MOSFETs that are doing the work, the outputs have usually Q. So this is Q12, and this one over here, these say like Q36. So Q is like a transistor or MOSFET. D is a diode. Now these ones will probably be fine. You probably don't need to test these ones. The ones over here, however,
can you chance that though? Like, it just sounds silly, just from a naive point of view. Like, can you chance that though?
No,
right?
you. The thing is, with the diodes, it's very difficult to test them in the circuit because they'll beep.
Right. They will.
They will beep, but that's they're designed to. So it's hard to test them in the circuit.
Okay.
So the only real way to test these is to pull them out of the circuit and use some kind of transistor tester, or you can use your multimeter if you know what you're doing. But to be fair, most of the time, these things they're not being driven by a drive circuit, and they're not directly connected to the output. So they won't generally. They're very, very rare to die. Only in a last resort, if you can't seem to get the thing working, and if you're looking for a short circuit, you can pull these out the board and see if the issue goes away. But yeah, generally they're absolutely fine. So if we look at these ones on the board here with your super head cam, you can see here that this has. I'll move your head.
Can you see?
I'm just gonna move your hat a little bit.
You can move my hat.
So this has quite visible damage here. And we can see that when we touch it
bad.
on the multimeter, we get a beep sound. So that is definitely a shorted MOSFET there. So this amplifier is quite badly damaged because there's quite a lot of these things that have an issue. So the amplifier is split into 2 halves. So just to give you a sort of basic rundown of how the thing works. So you see these 2 little sticky up boards here. Okay, these are like they're like the brains. Okay, the amplifier has 2 halves. So each half has a brain that controls it. Okay, the first half is the power supply side. So this bit from here to here, all it's doing, it's not doing anything to do with music or sound or audio or anything. It's just taking the 12 volts from the car battery and it's converting it into something that can run a speaker.
Right.
Okay. So because like a battery can't run a speaker on its own.
No.
You know, it's just a 12-volt battery. You know, so you need to change that into a higher voltage to drive a speaker backwards and forwards. So this half of the amplifier, all it's doing is taking 12 volts and making it higher and splitting it in half into 2 different voltages, like high and low. So everything that speaker goes in and out, so the voltage needs to be positive and negative. So this is how this amplifier works. It uses a positive and a negative. So this amplifier takes, this part of the board takes 12 volts, which is just a straight line, and turns it into positive and negative high voltage. So this is the little brain for this part of the board. So this is where you can kind of see, this is where this is the section of the board here. So this is the power supply. So the fact that these things are dead, these are the things that are doing the work on the power supply. These things are dead. So the power supply is dead. Now from here to here, this is the brain for the actual amplifier section, the audio section that's actually making the music. It's taking those voltages, taking the power that the power supply gives it and turning it into an audio wave, something that can actually make a speaker play the music. And these are the things that do the work for that. And these are also shorted as well. So the amplifier not only has killed the audio section, it's also killed the power supply section.
Great.
So we've got a few things to work on here. So generally, when you're working,
you said this wasn't too difficult, though. It's
not too difficult. Once you kind of look at it in 2 halves, so you treat this part as one separate repair, and you treat this part as another separate repair.
The left and the right side of the brain.
Yeah, kind of like left and right side, but you need both of them to get the end result, but they both do very different things, Okie dokes. Okay, let's have a quick look at the live chat.
Oh my,
okay. So, if I found a lady that could fix amps with me, I would consider myself a lucky guy. It's cool you have a friend that's into it as you do. Oh, okay, that's pretty cool. I wouldn't say she's into it, but she's very open to trying
I like
new
to learn new
things.
things.
Especially after a glass of wine.
Yeah, exactly. See, Sam has coaxed me in with wine, so So that's always good stuff. But also, yeah, I am generally interested in learning new things. I mean, who doesn't want to learn new things, right? And plus, like Sam's a good friend. Obviously he's really passionate about this stuff, so it's always good to learn, isn't it?
Adam says she's faster than you. Yeah,
Oh.
she's picking up.
Thanks,
Picking
Adam.
up pretty well. Driver board IC on most amplifier you deal with. IC number, the name, says Michael Timothy. IRS 21844S is the general drive IC chip that you find on the majority of these amplifiers. IRS 21844S. Have you told her to avoid putting fingers yet? Not yet. Fortunately, this amplifier isn't too powerful that we're going to have any risk of any like tingly feelings on the fingers. It's not that powerful.
Thank you so much for telling me that. Sam has not pointed out health and safety yet, which is
health and safety. We don't do health and safety.
Dude, you're my friend.
No,
like,
we don't. Yeah,
he's trying to kill me.
I wouldn't give you an amplifier that could kill you. So this one's perfectly safe. You're having no problems at all. Right. So the first thing that we're going to do is all the dead parts. We might as well get rid of them. Might as well cut them off.
Yeah.
Because they're no good anyway. So we're going to take our cutters here, and we're going to start with the power supply ones. These are the ones that are visibly damaged.
Yes.
Now these all run in banks, so they have a friend or they have friends that they work with. And if one of the friends goes down, then you've got to rechange all the friends. Yeah. So these work in banks, pretty much banks of pairs. These little things, these little donuts here, these need some of these to work. Okay, and there's always one that pushes and one that pulls. Pretty much, they work out of phase. So each donut will have two FETs that work with it.
Okay.
And by the looks of this amplifier, they've all died, every single one of them.
Okay.
So we're going to take our cutters.
Get rid of all of them.
And I just want you to go around and just cut all of these off the board. Let's trim them all off. Get rid of all these bad boys.
Okay. Let's see if I can actually do this.
Adam says, I'm glad she's got glasses on, mate, after that explosion you showed me.
No, do you know what? I'm not even joking. One, my eyesight's really, really shockingly bad at night time. But also the fact after Sam told me that, I'm like, yeah, ooh.
Yeah, that's fine. It can go on the floor. Don't need it anymore. No, it's dead. It's
yeah.
toast.
Also for safety reasons.
Yeah, the glasses for safety reasons probably quite good. I doubt we're going to see any explosions this evening.
I really hope not. I really hope not.
I like to think I know this circuit like the back of my hand. This is quite a generic board, so we should be fine.
It's just,
We're going to check all the drivers before we put any FETs in, so that's all fine.
Yeah, I think it'll be alright. It's also the fact that we're trying to get Sam into. Well, we kind of trying to get you into the health and safety stuff as well, aren't we?
A little bit. She's with the fumes. Actually, she's trying to get me to wear the fume mask.
Yeah, everybody out
she's
there.
She's very health and safety conscious with
the
solar flux and the solar fumes and especially the CA glue that digital designers use.
Guys, please wear stuff. Like, I worked in a lab and I've seen what stuff does. It's not good, so be careful. But yeah, I'm trying to make Sam do it. So Sam, you have to do it in front of everybody now. Like, we're on live streaming. If you don't, I'm going to pick up on it now.
Exactly.
You're in
trouble. I do have a mask now, so if I'm working with CA glue in future live streams, I will most likely be wearing the mask. Yeah.
I think it looks kind of cool. Like, it looks a bit sci-fi.
Yeah. Looks like a trooper or something.
Yeah. I think.
Yeah. Get straight in there. Rip them things off.
I'm gonna be so slow. Whoops. It's gonna take a little while. So, like, if you're doing this without, obviously, an amateur, how long would it take you?
If I was doing this without an amateur? I don't know. This has got quite a fair few issues. I'd say maybe a couple hours from absolute start to finish.
Okay.
Are we
finishing this long?
Say again?
Are we going to do all of it?
I don't know. We'll see how we go. See how long it takes.
Okay, I'm really sorry, guys, if you have work tomorrow, because this is gonna.
That's okay. Most of the viewers are in America anyway, so it's like afternoon time for them.
That's true.
Yeah,
that's very true. Yeah. Okay. Yeah, this one's really bad.
Michael Collins says I need to get the same O-scope as Sam. So the O-scope that I use, you might be able to see it here. Yeah, you can see the code in the top corner. It's a HP, so it's a 54602B. It's a really nice scope. It's not the best scope in the world, but it's absolutely everything you need for amplifier repair. You don't need much more than this really for amplifier repair. I mean, this is even a bit much for amp repair. But yeah, it's very, very good scope, really useful. Has all sorts of settings that you can use for amp repair. Really useful thing.
So, man. That's all this like white stuff.
So all the white stuff is basically amplified jizz. It's
Say what?
yeah, exactly.
You did not want me.
Getting your hands dirty already.
Yeah,
It's thermal paste. And it's the stuff that I come out of the workshop all over my face.
I wonder what that stuff was.
After a 6-hour live shoot, like all my jeans. You can see these jeans now.
I just didn't want to ask you.
Yeah,
like,
well.
Unfortunately,
these jeans are there like acid wash anyway, so they kind of have white bits in them already. But yes, all the white marks are thermal paste, guys.
Sure.
Thermal paste.
Sure, Sam. That's what you want to call it. That's what you want to call it.
Yeah.
This one is being.
That one being a bit of a stubborn bitch.
There
you go. You got it.
Yeah.
Modbug says I wear gloves so amp jizz doesn't get all over.
So that's very wise. Again,
it's wise, but the thing is with gloves I find that like I lose the accuracy. Dexterity. Fucking Miss Dictionary over here.
Sorry.
Yeah.
No.
I lose the dexterity with my hands. Like I need to. I like having my skin to feel everything I'm doing.
To feel the jizz.
Yeah, putting a layer on my. Yeah, I need to feel the jizz with my skin. Yeah, that's exactly what it is.
Ew, it's gross.
Okay, almost there with this.
Sorry, it's taking me so long.
No, it's good.
Right.
It's good.
So when do I become like pro? Well,
you're pretty much pro level already. I mean, yeah, the way you're cutting them FETs off is on point.
It's terrible.
Yeah, absolutely.
It's like, yeah, you can feel like it is a pasty kind of. It reminds me a bit of like clay. Like, have you ever done pottery?
Yeah, I've done pottery before.
Yeah, it's kind of like pasty.
Yeah, it's a little bit pasty. A little bit pasty.
What accent was that? Is that like Northern?
Well, I can't do accents, so it could have been anything really.
Sam twang. That's
Sam
what
twang.
Right, okay, last
There we go, last one.
Come on. There we go.
Alright, so
Sweet.
all of the MOSFETs are off. So we have, what remains now in the board are all the legs from those MOSFETs. Now we can keep those in just for the time being. We're going to run a couple of tests on this amplifier first before we need to remove those. So the fact that we've got rid of all the dead MOSFETs should mean that there's no longer a short circuit across the amplifier's power inputs, and that's very important. So the reason that these FETs blow and smoke up in such a terrifically bad way is because when they go short, they create a direct short circuit across the amplifier's positive and negative terminals. Now obviously you've got a car battery connected here, so there's shit tons of current on tap. So when these make a short circuit and there's a battery there, then what's going to happen is those FETs are just going to cook and cook and cook because there's nothing to stop them. There's nothing to stop the short circuit, other than if you've got a fuse in line, which obviously you should do, unless your team no fuse. And obviously the fuse doesn't blow instantly, so that's why these things cook up like crazy. And so now that we've removed all of those things that were shorted, we shouldn't have a short circuit on there anymore. So if we take our multimeter here that we had earlier, if you take your two probes here, so there shouldn't. So if you put one on here and one on here, it should beep for a second, but then the numbers should start climbing up on the screen here. So you see the numbers are climbing up and up and up, and it's not beeping anymore. So that means that the amplifier is now basically the meter's charging the amplifier. Okay. So you see these little things that look like batteries here. They are a bit like batteries. They hold a electrical charge, but they hold it. They can suck it up very quickly and get rid of it very quickly. Whereas a battery takes it takes a long time to charge up, takes a long time to discharge. Whereas these things are like instant. They take a charge instantly and they then release it instantly. So what we were doing there, this gives a very small electrical current. We were charging these, which is why the number was going up and up and up. It's like charging it higher and higher. Okay, so now that we've removed all these FETs, like I said, I told you these are the things that do the power. Remember I said about the three men? You have the weak piddly man, the middle man, and the really strong man. So these are the strong men. So we got rid of the dead strong men. They're dead. Okay. So the middle men are actually. So see if we can zoom in. So if you like look down with your head, so you can see on the board here. The middle men are these black things here. So move this out of the way. So these are basically they're doing the same sort of job as these ones, but they're just passing the signal onto them. So these are like the middlemen. So we've got 4 here, and then we've also got 4 here. And these are called the drive transistors. So these are the things that drive the big strongmen, the big MOSFETs over here. Now sometimes when the big strongmen die, they also kill middlemen, but not always. But it's very difficult to tell, and they don't always go short with a beep like these do. So the way that we check whether these are dead or not is we put power into the amplifier, and we see what sort of signal they're passing. If they're passing a good signal, then they're probably fine. If they're passing a signal that looks a bit shit, they're probably not fine. So this is the point where we actually put some power into the amplifier and see what it looks like. So I'm going to plug the wires in over here to the amplifier. Modbox. I just realised that's the same board as Twisted Audio. I haven't tore into much, but I removed all the power FETs. But speaker terminal get 15 volts DC, and every part gets the same around output section. Gets same around output section. Yeah, Twisted Sounds is also made in Korea in Xenon, so that would make perfect sense as to why this is the same board. So hopefully this video will be useful to you. I don't remember which one's there, which one's which. There. Yeah, that's good. As soon as I get back to my bench, I have a couple of questions to ask you about repair, Sam, says Brian. No problem, buddy. Shoot me a message on my Bearviz Facebook page, and I shall get back to you. I don't look at that. I don't look at the messages on there every day, I'm not going to lie, because it's kind of crazy busy on there. But if you shoot me a message on there, I will get back to you within a couple of days. Okay, so let's turn this over. So we're going to put a little bit of power into this board. So I've got my my power supply over here. The camera seems to be a little bit glitchy. Let's sort that out. Put that over there. So yeah, we're going to turn our power supply on, and we're going to shove a little bit of power into this board, and we're going to read the drive waves to the power supply section. So that's set to 14.5 volts at the moment, so we're going to crank that down a bit. When we're testing an amplifier like this, you only need about 9.8 volts, and having a low voltage like that actually keeps things nice and safe. It reduces the rail voltage on the output section to quite a low value, which means that if there are any issues with the amplifier, then you get a bit longer to notice the issues before things start exploding, which is very handy. So I'm going to put about 9.5, 9.6 volts in here, and to test the drive circuit we literally need about an amp, so I'm going to only put about an amp into this board for the time being. And we're going to have a look at the scope. So you see the screen up there, the screen up there is our eyes, it's our vision into what the hell the amplifier is doing. Because when you look at a circuit, you can't see electricity. You can't see it, but you don't know what it's doing. So this is like our eyes into what the amplifier is doing.
So we said the other day, like being at a hospital, kind of like monitor screen with the heart rate.
Yeah,
actually looking
you can pretty much see what the different parts of the circuit are doing just by touching this probe on there and looking at the screen. This is like our eyes into the amplifier. So these middlemen over here, the drivers, they will put the signal onto the first leg. So you know these have 3 legs of these. So leg number 1 is what the signal goes into. So leg number 1 is these ones over here. 1, 1, 1 on this side.
So it's always on the right
side. And then on this one it's 1, 1. So that we're looking at the other way around. So if you take this and you touch it on number 1 over there. Okay. Let's move your hat up a little bit. Just so I want to get the angle right. That's about right. So if we move it onto number 1, okay, and then I turn the amplifier on, and we look at the scope up there, we should see, hopefully, some kind of waves appear on the screen. I might need to turn that down a little bit. Okay, there we go. So there is a nice square wave. So that's the signal that the middlemen are sending to the big men, and that's the turn-on signal. So the square wave when it's up, it's on, and when it's down, it's off. So they're basically telling the big MOSFETs to turn on, off, like in a square wave format. So we can zoom out a little bit and see that there's a square wave. So that looks like a pretty good shape actually.
Yeah.
So what we want to do is we want to keep the amplifier on, and you want to go along and make sure that that wave looks the same on all of those number 1 pins. But that looks a bit different.
Okay.
So if I pause go back to that one again.
Yeah.
Okay. I'm going to pause the scope.
Yeah.
And I'll go back to the first one. I'm going to start the scope. You see how that looks different?
Yeah, okay,
it's
quite a bit
lower,
difference, yeah.
and also it turns off slow. There's like a dip at the end here.
Yeah.
So that's not really that great. There's some problem there. So carry on going along, and we're going to see how many of those have that bad shape. Yeah. So, okay, what are we on now? So let's go to the third one. Okay, so the third one... Oh, where is it gone?
There it is.
The third one has that problem as well.
Yeah.
Okay.
So it's like the first one, isn't it?
Yeah, and then go to the second one. That one looks okay.
That one's that one's like the second one as well.
Yeah, that one's the second one as well. Yeah.
Okay, this one. Let's have a little look.
That one's bad.
That one's.
By the looks of it, press it again. Go on it again. Yeah, so that one's not good.
Sounds like the first one.
That's like the first one
third
again.
one.
Yeah, and then go along to the next one. That one's looking okay. Look at the screen again, that was looking okay.
Yeah.
So remember how I said that these run in pairs, okay? So we've got one, so you see what these donuts on here?
Yeah.
Oh, yeah. You've always got them in pairs of 1 and 2. So it looks like 1 is doing like the pushing, for example, and 2 is doing the pulling. So the 1 is the one that, 1 and 1, these are the ones that look bad.
Yeah.
So the drivers here that are driving the push are obviously possibly faulty on this side, but the ones that are doing the pull are probably okay. So if we go along and do the same thing on this side, and so we're looking at doing that one there. Okay, so that one looks okay.
That looks good.
Yep.
This one. Sorry.
There we go.
Whoa, okay,
that looks even worse.
That's
okay,
terrible.
so that's the pull this time that looks pretty bad. Okay, go along to the next one. That looks okay. Yep.
That looks good.
And go along to the next one. That looks pretty bad. Okay.
There's a trend. That looks good.
Yep.
And this one looks shocking.
Looks pretty bad. Okay, so it looks like in this case then that the big MOSFETs here, they killed some of the drivers.
Yeah.
Now like because these are small parts, they're pretty cheap. It makes sense just to replace all of them. So you know how some of them were kind of okay, and some of them were kind of not bad. Might as well just replace all of them because they obviously got hit kind of slightly bad.
Yeah.
So it makes sense just to replace all of them. So I have some replacements for those in here, and I have some upgrades. We're going to put some beefier ones, so some bigger middlemen in.
What makes them better?
They can handle more power. So it means that if there is a they'll run cooler. So if obviously you put strong middlemen in the middle, then they're not going to get worn out so easily.
Okay, they'll last longer.
Yeah, they last longer, and they're not doing much work. It's like a light load for them. It's
okay, so they'll support the bigger guys.
Yeah, they'll be able to support the bigger guys much easier.
Okay.
So there's two types of middlemen. Think of like male and female, I guess. But you have some that do the turning on. Right. So you know the wave goes up and down. Yeah. So when the wave goes up, that's basically one of them going go up, and then the second one goes no, calm down.
So
they do push and pull. Yeah. Okay, so you have the drivers. There'll be a push driver and a pull driver and a pull driver essentially. One that does the turning on, and one that pulls it down and turns it off essentially. Yeah. Yeah. So
they look slightly different.
They look exactly the same, but they've got different codes on them.
Right.
And the replacements that I've got in this drawer, they do actually look different. The ones that do the pushing, the ones that do the turning on, most of it, are these ones, and they have like a silver back like this. Okay. Just because that happens to be the ones I have. And the ones that do the pulling and turning off, these ones have a black closed back like this. And for those of you on the live stream that are interested, the drivers that I use here, the turn-ons are the BD139s. The turn-on isn't that important. The NPN, which is the turn-on driver, this isn't that important in terms of speed. All this is doing is amplifying the signal to the gate. The one that's really important to be fast and high power is the PNP, the pull down, because you need to turn these power supply FETs off really quickly and with high power. So the B772 is a really good transistor to use for the PNP in the drive circuit. So we've got 8 of these here. We've got 4 over this side and 4 over this side. So we've got 2 and 2 over this side. So what we're going to do is we're going to replace all of those. So I need to get 4 of the NPNs and 4 of the PNPs. Let's get those out just now.
Modpod Boxer has a good question for you.
Modbox says, does 50 N06s have 2 BD140s? I thought one had to be 1 through 9, one had to be 140. There's Modbox. There's a good question. There's 2 different types of drive circuit. Okay. Actually, I should check which type of drive circuit this is, because I may have. Oh no, this is the first type. This is the type that I just described. Right. There's 2 different types of drive circuit, Modbox. There is the NPN and PNP drive circuit. And the NPN-PNP drive circuit is basically the NPNs are amplifying the drive signal and the PNPs are pulling it down to ground. If you don't have any NPNs, if you only have 140s or A drivers, so if you only have A1023s, or if you only have PNPs in the drive circuit, then the turning on of the FETs is being done pretty much from the TL494 signal. There's not really any buffering of the signal. The TL494 is pretty much driving the FETs directly, but the PNPs are pulling the signal down to ground quicker than the 494 can, and because the FETs have gate capacitance, the 494 doesn't have enough kind of power, enough oomph behind it to pull down all of that gate capacitance to ground quick enough for the FETs to turn off. So you use a stronger PNP transistor to pull the drive signal down to ground, so the FETs all turn off at the same time and quickly, ready for the next turn on. So if you have a drive circuit that only uses PNPs, then you can just run BD140s or B772s through that in that drive circuit. But if you have one that uses NPNs as well, then essentially they are buffering the 494 chip, and you know they're taking the signal and amplifying it a little bit to turn the FET on, as well as the PNPs to pull it down. So we have 2 of those, 2 of those. So we need 4 of each. 1, 2, 3, 1, 2, 3, 4. 4. Okay, there we go. So we've got 4 of each now there.
Nice, okay, perfect.
Now we're going to do some soldering.
Oh, okay.
Yeah.
Now I'm scared.
Let's have a quick look at the live chat.
Yeah.
Greetings from Newport. Great idea for a video. She's a really good sport. I assume she's very intelligent. Absolutely, actually,
No.
very intelligent.
No.
Oh, I doubt she'd have the intellectual curiosity to even bother.
Aw.
Yeah, absolutely.
Thank you very
Class
much.
AB says Dennis. No. This is Class D mono amplifier. Still trying to figure out 4-channel audio bomb. Blah blah blah. Send a few board shots. Yeah, send me some shots. I'll see if I can help you out. Hello to the Real Race Fury. How's it going, buddy?
Hey. Hello.
So, how many people are watching just now? I've enjoyed 76 viewers.
Oh
Awesome.
my
Very
gosh.
cool. So 70 people will be watching. Okay, so yeah, we're gonna do some soldering now. So in order to remove these things,
Okay. Right.
I mean, because we're not going to use them anymore, you could snap them off the same as we did the other things. That might be the quickest thing. So rather, you can't really get the cutters in
No,
here.
I was going to say it's so small.
You can't really get the cutters in there. So what we're going to do is we're just going to if you just wiggle them backwards and forwards.
Yeah. Can you like twist it and pull it off?
Yeah, just wiggle them backwards and forwards like loads of times, and eventually it will just a couple of times like that. You can feel it getting looser,
And then you can just.
and then it will just pull off like that. It just come off like that. So if you do that very quickly, lots of times, get rid of all. Actually, we have to remember which location they were. I'm just going to remember. So you remember I said there's 2 types, like a male and female, push and pull. So the ones that are doing the pulling down have an A on them, and the ones that are doing the pushing have a C. So it looks like we've got a C in the middle there. That one's a C and that one's an A.
Okay,
so we've got A's on the outside, C's in the middle. Okay, so that's how we remember that.
Okay.
Yeah, we remember that.
Okay, let's get this.
Jesse, how's it going? Good evening. This is a really cool live stream for you to see. Glad you're joining us, Jesse.
Hey.
JK Photography, hello from Sweden. Good evening from Sweden.
Hello.
Good evening from the UK.
We were speaking about Sweden too, weren't we?
We were talking about Sweden
We
a bit
want to go
earlier
to
today.
Sweden.
I would love to visit Sweden at some point soon. I'm a massive fan of the HPC, the Hydraulic Press channel, and the Beyond the Press channel, and Anni's vlogs, and also Sari's video logs as well. Their good friend Sari with the crazy colour hair. She's very cool. And I'd love watching those videos, watching their videos has made me kind of really want to visit Sweden.
Aww,
it seems really cool there.
It's kind of inspired you today.
Yeah, definitely.
That's awesome.
What is the switching frequency of a Class D output drive? Says John Brass. It very much varies on the amplifier, and it depends whether it's a subwoofer amplifier or a full range amplifier. Obviously, the higher the switching frequency, then the higher the bit rate, if you like, of the output wave. So the more times the MOSFETs can switch, then the more data that they can basically create, the more steps there are in the sine wave. So if you've got a subwoofer amplifier that's only really playing up to like 200 Hz or 500 Hz max, generally subwoofer amplifiers have about 125 kilohertz or 130 kilohertz switching wave. For a high quality bass amplifier, the highest that I've seen in a bass amp is about 350 kilohertz. For a full range amplifier, I've seen them as high as 650 kilohertz on the output section. Yeah.
So can I just say I love the message from Josh, who's like, Sam, are you two drinking and repairing? We are. It's very dangerous. It's like drinking and driving, but we're drinking and repairing.
We're drinking. Yeah, I've done many videos of drinking and repairing. As you see, if you go on my channel, I've done a boozy amplifier repair evening where we repair some fly amplifiers, and also a HIP 4080 Hyphonics after many glasses of wine and spirits, which was good fun. So yeah, I'm you know, if I'm doing repairs after some drink, then I will only repair amplifiers that I own myself, because I am responsible like that. I don't want to work on a customer's amplifier if I've had a drink, because that's not responsible or good business practice whatsoever. However, this amplifier belongs to myself, and so I'm letting Ashley have a go, and we're having some wine and having a good time.
I would never try and...
Yeah, no, absolutely. Good evening from Belgium. How's it going? I know Lawrence Vasterson. Lawrence is a good. Actually, Lawrence sent me this. This is an amplifier from Lawrence himself. So yeah, if Lawrence is watching, or if you know Lawrence, this is an amplifier from Lawrence that he sent me not too long ago. What do you think of the new video from Ryan B? I haven't seen that one. 91% efficiency.
Whoa.
I don't think that it would be 91% efficient at 1 ohm. And at low frequency. It's probably 91% efficient at 4 ohms and at 1 watt perhaps. But I would be curious to see the video, so I will check that out. Thank you very much for telling me about that. Everyone watching for Sam a lag. Thank you very much to Tom for that very kind suggestion there. Right.
I agree, Tom. Sam does an awesome job, bless him, with his live feeds.
Okay, cool, right. So yes, so we've snapped, so yeah, well done Ashley, you snapped off all those transistors like a boss.
Sweet.
Snapped off them all off like a boss.
Hi from South Africa, Scott.
Yes, evening from South Africa, evening to Scott. If you're in South Africa, then you might know of a guy called Louis D, who goes under the company of Black Dog Repairs. He repairs amplifiers in South Africa to a very high standard, so you may know of him. And he's a very good friend of mine, and he taught me a lot of what I know about amplifier repair, so that's pretty cool.
Yeah, I was going to ask, how did you actually repair?
Yeah, it was mainly from just buying blown amps and pissing around and trying to repair them, but also I got a lot of help from a good friend Louis, who now lives in South Africa. And also Gordon at Am Doctor, he actually did a lot of help for me as well.
That's really good.
So, soldering time.
Oh
now,
my. Okay.
So those transistors that we removed earlier, those drivers that we're killing. So let's move your hat. Let's keep your head still. I'm just going to move your hat around a teeny bit. There we go. So the ones that are on the other side of the board, the legs. So you know how 3 legs. So you've got 1, 2, 3. They're all here. So you've got these 2 here. And these 2 here.
So what were those in the middle there?
These are resistors. These are just little things in between them. Yeah, leave them there. They're probably fine. So we're removing these 2,
and
these 2, and then these 2. You can see they're the ones with the legs that go off to the angle.
Yeah.
The ones that go in towards each other are fine. Ones that go off to the angle we're removing. So we're removing those 2. Okay. And you can see there that's got a def. That's definitely burnt and blackened there. So that's why the wave looked pretty shite earlier. Okay. So what we're going to do is we're going to turn the soldering on. And like I said earlier, what we're going to do...
I'm going to watch you do it first.
I'll do one first. So we're going to turn the soldering on. You hold it there and you can see when the solder goes all like liquidy, melty. Hold your head still. Turn the camera around a little bit.
Sam's sorting out my style.
Sorting out style. And when it goes watery and melty, what we can do is we can either do it from the top. So we do that from the top, or... hang this off the edge a little bit and do it from the underneath. It might be better actually, so you kind of guess roughly where that's going to be underneath the board there. Yeah.
And try and catch it.
And then you do that, and then you do it like that. Press the button, and it sucks all the solder through. So let's turn the soldering iron on. Let's turn my camera up Wait, what am I doing? Wrong pedal.
Ah.
That's the wrong one to do. So yeah, we've got our soldering iron up here. So we're going to turn the soldering iron on, the fume extractor, because that's very important. We're going to put a temperature of we're going to put about 380. Not too hot because these are only small pads, so we don't want it to cook up too much. Glass of wine is making crazy noises. It's not got any wine left in it, sadly, so I'll put it down there.
Okay, you can have some of mine if you want.
So it's getting pretty hot now. So what we're gonna, So if I do the first one, let's just see how well this is gonna work. So I'm just gonna sort of put the iron on there. So you have to sort of wait, and then you can see where you see now it's still starting to go liquidy, molten-y there. Just trying to come up a tiny bit. And then what we're gonna do is I'm gonna try it from the underside first. Okay, so it's taken most of the solder out, but it's still left a leg in there, and that might happen. Now, this is so you just have to kind of try a couple of times, try and get the leg out.
What if you go from the top? Can we see how it compares?
We can see how it compares going from the top. Okay, so the top seems to get the leg out pretty straight away. Yeah. So yeah, maybe going on forward we'll go from the top. So if we do this one next. Yeah.
This so reminds me of DT days.
Yep, that pretty much takes it out nicely.
Nice.
Now, because this solder is quite old, sometimes it struggles to suck up. So, what a good idea might actually be to do is to actually put some fresh solder, which is nice and sort of liquidy, and on all of these. So so hold that there to heat that up a little bit. Put a little dab of fresh solder, and you can see it kind of like makes it all shiny, and it freshens it up. So we're just going to go ahead and put some fresh solder on all of these, just to make the solder suck out a lot easier.
Okay.
It's a little bit of a waste of solder, but it's you're not using too much of it, so it's not too bad.
How expensive is solder?
For a big roll of it like this, I think is about 15 quid.
Okay, it's not too
and this probably lasts me like maybe 3 to 4 months, I'd say.
Whoa, okay.
So it's not bad. Yeah, it's not too bad at all. And it's always worth using leaded solder. Now, leaded solder is a little bit more dangerous because it's got lead in it. Yeah. But the lead-free solder, from my experience, is absolute shit. It's like trying to work with cheese. It just doesn't work. Right, so take this in your hand.
Oh gosh, okay.
Just careful not touching the end, obviously. Well, I'll take that in the other hand. Yeah. So what you want to do is touch it on the on that one there. You'll see when it goes liquidy like that. So you want to do it really quickly. So it sets really quick. So you want to pretty much put that and you can touch that on the iron.
Shit.
Oh, there you go. That's all right.
Sorry.
Just put that down again.
Okay.
So pretty much, yeah, you want to press the button as you remove the iron. It's a very quick sweeping motion.
Nice.
So what you want to do, see how this has got a like a rubbery end on it?
Yeah.
This makes an airtight seal to ensure that it sucks up the solder. So if you put the iron on there, I'll show you what I mean.
Okay.
Okay, so what I'll do is I'll count it down in 3, 2, 1, and this is very
keeps like going up.
It keeps going off. So in 3, if you remove the iron, and I'll do the sucking. So ready? 3, 2, 1.
Nice. Okay.
So that's a very quick motion. So and then we've got a little bit in the middle one now, because of how it goes. So if we do 3, 2, 1, nice. There we go. So now that holds free.
Okay, ready?
So there you go. You have a go.
Okay.
John says, why are you not using your desoldering gun? I'm not using my desoldering gun because it's absolutely rubbish. It is the worst piece of crap I've ever used in my life. It clogs up every 2 sucks, which means that it takes twice as long to desolder anything compared to using the desoldering pump. The desoldering pump I found very efficient, reliable, doesn't require any maintenance. It just works and works and works. Until I can save up and buy myself a decent desoldering gun, maybe like a Hako or something, and then that'll be better. But for the time being, the desoldering pump works perfectly fine, and where I'm used to using it now, I'm very efficient with it and I can do it very quickly, so it's not a problem at all.
I can't, man, I don't think I can do it.
Yeah, it's all about the speed. It's like a very quick, because it sets so fast.
It does.
It sets so quickly.
Yeah, sorry guys, I'm going to try and be really quick. This right.
Well, you can suck it whilst the iron's still there. If I pull this down a little bit, there we go. So you got a bit more rubber on there.
Can I just
So you can hold it there, and you can probably suck it pretty much while the iron's there. But you got to make sure you make it airtight seal. So it's not quite quick enough. So if you hold that there, we can tag team this.
Can we tag team it? Yeah.
Oh, whoops.
Well, that kind of worked.
Okay. 3, 2, 1, go. There we go. That's that one.
Okay, Sam is a pro, so I'm just gonna let you
3,
do
2, 1. 3, 2, 1. There we go. So that's pretty much that's there. There's a bit of a leg, a little bit of a leg on that one. Where's my tweezers gone? Here we go. So we're just going to move this leg here like that, and this leg like that. Perfect stuff. So now we're going to move on to the other two up there. 3, 2, 1. Oh, you kind of almost missed that one. Come back for that one. 3, 2, 1. 2 in 1.
Whoa.
Oh yeah.
Okay, ready for the first one?
3, 2, 1. There we go. 3, 2, 1. 3, 2, 1. Oh, nearly. 3, 2, 1. Come back to that one as well. Yeah, okay. 3, 2, 1. Ah, no.
Come back that way.
3, 2, 1.
Man.
Okay, so I'm not sure that one is actually melting nice and easy.
Just like, it's kind of...
Yeah, if I do these last two,
yeah.
just get it out of the way. Matt says, I love watching these live streams when I can catch them. People that freely share information and techniques are literal saints. Oh, thank you. I just don't think there's enough people in the world at the moment that are, you know, into repairing stuff. It's a very throwaway society, and I just want to get people back into actually fixing their shit rather than throwing it away, sending it to a landfill. Most of the time, faults with things can be fixed really cheaply for very little money, especially with electronics. Electronic components are very cheap, so if you know what the problem is, you know, you can fix it for really cheap. So yeah, rather than throwing it away and spending your good hard-earned money on something new, you might as well just get a bit of knowledge, buy a couple of parts for a few quid, and then you can make it work again. It's a brilliant feeling when you make something work that was broken. It's a brilliant feeling. It's like a feeling of accomplishment.
Yeah, definitely.
And you've beaten it, you know? This thing was broken, and you've beaten it.
It's nice, so yeah, like you said, it's the whole, like, we've got this throwaway society at the moment, and we're so wasteful of stuff as well, and I think it's just, yeah, it's a shame.
It is a shame. It is a shame. Ashley's right. Be like Ashley, guys.
Don't be like me. But don't throw away stuff.
Okay, you want to move your camera so, yeah, look on. I think so. I think if I move the camera up a little bit, pull your hat back a little bit. There we go. Yeah, that's good.
Easy away. Cool.
Okay. Okay. Well, I think we've pretty much taken all the old solder out of these holes now. Slight solder bridge there.
Yeah.
Get rid of that one. Just get that one in that hole a little bit there. Okay, we're just going to put a little bit of fresh solder because that one, the solder's not coming out very nicely. So we're going to put a little bit of fresh solder on there just to get it all soaked up together. There we go, much nicer hole there.
Very neat.
Very neat. Okay, cool. So yeah, all the solder has been sucked from the holes of those drivers. I can turn the soldering off now. So now if we flip the board over, Hammer Knock says, "Yep, love the stream. I'm into repairing. Good stuff.
Aww,
good stuff."
Great.
15 volt rails collapses to 5 volt. Oh, that's in reply. I have an amp that accepts input on the slave mode, but nothing to the regular input mode. That is probably going to be either snapped RCA connections on the regular input, or it's a blown op amp on the main input, probably a TL074C or something like that, or a JRC op amp. But yeah, basically the slave input directs the audio signal directly to the driver board, so it bypasses all of the op amps in the input section. So if you've got no sound coming through the regular inputs, but you have on the slave input, then obviously that means that either the signal's not getting to the op amps or the op amps are faulty. So you can take your scope and find where in the input section the amplifier is losing the signal, whether it's getting to the op amps and not coming out the other side. So you can use that to find out what's going on. Very faint sound in regular input, so that sounds like a cold solder joint or a faulty op amp. So yeah, go searching for issues like that, my friend. Cool. Okay, so let's have a look. So yeah, the top of this board looks not too bad now. That hole looks a little bit janky there. Janky hole there. I think maybe it will still fit through there. So we've got our new drivers over here. our new driver transistors over here. And these have to go in the right way. So you see the little the markings on the board. I'm going to angle your camera down a little bit.
Yeah.
There we go. So if we look at the... Oh, damn, I angled it down too much.
It's all about how you wear your hat, right?
Yeah. So, yeah, the markings on the board here. See how they've got like a flat edge and a back edge. So the flat edge generally always is where the markings are on the transistor. The transistor has like lettering on it and its code. So the code goes on the flat edge. So the ones that we're doing the pulling down are the B772s, which are these ones. And the ones that are doing the amplification are the BD139s, which are this one.
Yeah.
So these ones, we're going to go on the outsides. Right, I'm just going to see whether this is going to go through that hole. Because that hole's... Oh yeah, it does go through that hole. Okay, cool. So if you want to take...
need to switch that round. Was the code on the right side?
No, code's on the right side there.
Yes. Okay.
Yep. So you want to take that one. Put that in the hole on the next one. That's the 139.
Did you say though? Sorry, Sam. Did you say you wanted the code?
So the code's on the flat side of the marking. So you see the marking on the board. Yeah, that's perfect. Yeah.
Okay.
I have a Hyophonic Zeus 500 times 2. Powers up, plays fine, but when you switch on the car, it goes into protect. Yeah, so that's weird. So there might be something leaking on the output section that only leaks to a bad extent when the rail voltage increases. So when you turn the car on, Mr. Link there on the live chat, when you turn the car on, the voltage goes from 12 volt to 14 volt. Yeah, that's perfect. That's perfect. And when you go from 12 volt to 14 volt on the input, the rail voltage rises quite considerably. So if there's anything leaking on the output section that doesn't trip the protection on 12 volts, as soon as you increase the rail voltage and go to 14 volts, then it's enough to trigger the protection. It's possibly something like that. But those issues are really weird and hard to find. I've got a Hyophonics amplifier myself that plays beautifully on 12 volts, but as soon as you put 14 volts into it, it makes horrific sounds and distortion through the speaker outputs, and I haven't actually been able to find out what the bloody hell the problem is yet. So it could be something with the op amps on the input section. But yeah, those issues are usually very unique, and there's not like a generic general answer. You just have to use your scope and try changing parts until you find the problem. 5 Taco says, do you have an electronics engineering or other degree? No, absolutely not. I have never taken an electronics class in my life. I've never done any kind of engineering or electronics classes or degrees or anything like that. All I did was I bought a load of broken amplifiers. I spoke to my friend who repairs amps, and he gave me a few tips, and I just tried to repair them, and I learnt along the way. So I just trial and error, tried to fix it, didn't work, worked out why it didn't work, and just learnt from there. So that's why when on my live streams, sometimes I lack some of the basic knowledge. I lack some of the spec sheet knowledge. Some of the I can't really read schematics that well, and stuff like that. But I can generally repair any amplifier you can throw at me. But that's why, yeah, I lack a lot of the basic knowledge. But the kind of practical stuff I can deal with pretty easily, because that's what I've learned. That's what I've been doing all this time.
You're a really good problem solver. That's what
problem solving, yeah. Problem solving I love. That's why I enjoy this work.
I'm in awe of it. I would be terrified to like just buy a load of stuff and like try and fix it without.
Yeah, most of it was all really cheap stuff. So, I mean, thankfully, a lot of people donated a lot of blown amplifiers to me as well. They wanted me to get up and running with learning how to repair amps and stuff. So it was very kind. Lots of kind people donated amps to me to repair.
What got you though into actually trying to fix amps?
So what got me into actually trying to fix amps is I became the distributor of Banda Audio, which is a Brazilian make. And nobody in the UK really knew how to repair those amplifiers. So when I got customers that blew their amps, I would have to send them back to Brazil. Now, I never actually sent one back to Brazil because I thought that was very expensive and it was not really practical. So when I had customers that came back with blown amplifiers that were within warranty, I thought, shit, I've got to learn how to fix these, because otherwise I'm just going to have to give the customer a new amplifier and I'm just left with all these broken ones I can't do anything with. And these are expensive amplifiers. They're like the Bar Viking 7K, so it's costing me like sort of £500 a pop. So I didn't want to be left with like thousands of pounds worth of amplifiers with a few blown MOSFETs I couldn't fix. So I just thought, okay, screw this, I need to fix these because otherwise it's going to be a problem. So I made that my challenge. I learned how to fix them, and that actually got me really interested. I enjoyed it a lot, and then I thought, oh shit, if I can fix these things, let's try some other Korean boards and let's try some other things. Yeah.
It's past your bedtime.
Sam, it's past your bedtime.
It is.
Really?
It's definitely past your
It's half 10.
Actually,
Okay.
you stay up late.
David, you have schematics? Send us some. I don't have any schematics at all. I don't use schematics to repair amplifiers. I mean, I've got a few schematics for some Alpine amplifiers, some schematics for some Tarams, which you can get online anyway. You don't need me to send them to you. You can just Google them. I've got a couple of schematics for some old Rockford Fosgate stuff, but generally I don't really need the schematics. I can just see where the circuit's going on the board here and just work it out from that. Yeah, I'm going to get us some more wine. I've run out of wine.
Do you want my one? Because I don't think I should be drinking while.
Yeah, absolutely should be drinking wine. Yeah, absolutely should be drinking.
Right.
Okay, so we've pushed the transistors into the holes here, so they're all ready to be soldered. Yes. So what we're going to do now is we're going to solder them. Okay. So if we flip the board over, push those ones all the way down.
Tightly, snugly in.
I believe so. Tightly, snugly, tightly, snugly.
Snugly, snug. Right.
Okay, flip that over like so. You can see all
pretty.
It's lovely, yeah. It's cool. A nice quality build. This one.
Piece of artwork.
Piece of artwork.
Yeah, no.
I'll tell that to Mr. Chang at Xenon Factory. Yeah.
Please do send my love.
Okay. Right. So we can take our soldering iron. Now this is slightly the wrong tip, so maybe I should. Yeah, I'm going to change the tip to something easier for you. Okay. I get lazy. I don't usually bother changing the tip because I get lazy. But we're going to change the tip for a nice thin tip. It's got a little bend on it. Everyone likes a bendy tip.
I hear they're the best. Right. Okay.
Yeah, the bendy ones can access all the right areas. Yeah.
Sam, it's not that kind of video.
What you need is.
Okay. Wow, it's aging.
Was being sarcastic. Oh, sorry, Dennis. I am really bad at picking up on sarcasm, so apologies. Especially over text.
Yeah.
Especially on written word, I struggle to pick up. I build and repair tube guitar amps on the side. It's something I really enjoy and love helping out broke musicians. Matt Field, that's wicked. Yeah, absolutely. I wouldn't have a clue where to start with tube amps, so that's really cool. Something that definitely I'd love to have that knowledge as well. Sirius, what headgear are you using? What headgear? So the webcam that's attached to Ashley's head is actually a Logitech webcam. It's just something from like 2005 that's duct taped to a baseball hat.
Pretty cool. Quite comfy. Yeah. You should sell this stuff.
So it's nothing high tech at all. It's just some basic shit. Anyway, right. So, soldering iron's hot, be careful. Take the soldering iron there. And what we're going to do is take some fresh solder. So this
what you do first?
Okay, I'll demonstrate one first. Okay.
Yeah. I think I'm better at like seeing and learning and stuff.
Alright. So, what we're going to do is each leg needs to have a fresh solder on it. So we're going to take this and we're going to touch it on the leg and the pad. So you want to try and touch both at the same time because they need to get hot. So that the solder flows. The solder only flows onto hot things. Yeah. So we do that first, and then we touch the solder onto the iron to melt it, like that. And you see it will start to flow onto the leg once because the leg's hot. And then we let go, and you see there's a nice little mound of solder there.
Yeah. How much you?
Just a tiny bit. You don't need much on these. Okay. So just do the one just behind it as well. I'm just going to move your hat actually. So if you keep looking where you're looking, I'm just going to move your hat so that it's actually.
Sorry, guys.
Focused on the. Yeah. I'm stepping away, but leaving the stream playing. Says Jesse. Enjoy whatever you're doing. So yeah, this one. So we're just going to heat that up. Touch the solder on the thing. You can see it makes a little mound. Yeah. And then let go, and that should be soldered.
Nice. Okay.
So your turn. So touch the leg first there, let it get nice and hot, and then touch it on the iron. Now you see here the iron's touching the leg we did before.
One.
So yeah, you just got to angle it right so you just touch that one leg.
Yeah.
There we go. Hello to Eric. Hi, how's it going?
Hey.
Hello to Adam, how's it going?
Hey Adam. Hey Eric.
Yeah, it was great.
that
Yeah, good job. Yeah, that's good.
Oh,
yeah,
sweet.
nice.
Okay.
Yeah, looks good. Got the hang of that. So now those ones are done, they're kind of in the way.
Yeah, so we should.
So I'm going to blow on those and just bend the legs back a bit like that so you can
way.
access the next ones there.
You did the first one, didn't you, for me?
I did the first one.
I like that. Is it weird to like the smell of the solder?
Well, things that smell good are usually very bad for
I
you.
know. It's like I like
So
the
it's
smell of
like,
petrol.
it's like
I
petrol,
shouldn't.
yeah, and
paint.
CA glue
Yeah.
smells bad and
All
it's very
the bad
nice.
stuff.
All the bad stuff, yeah.
Why does it smell good?
Okay, yeah, is that all those three done? Yeah, wicked. Let's move on to the back two.
It's kind of
Is
weird.
this what you thought it would be like?
Yeah, it's kind of
Is it kind of cool?
therapeutic.
Yeah, it is, isn't it?
Yeah. I was really scared. I'm not gonna lie, everyone like to do the soldering. I haven't done soldering since I was like 13 in DT class, and I totally forgot. And watching Sam do it the other day, I was just like, I can't do this. But it's very therapeutic.
Yeah, nice one. That's even good. Bend that out of the way.
Uh-huh. So, Sam, question for you.
Question for me.
How long have you been doing your live stream for now?
I think the first live stream I did was in February.
Ah,
So, yeah, a few months now.
how are you finding?
Yeah, pretty good. Pretty good fun.
So you like got a nice crowd.
It's a lovely,
Isn't it
lovely.
amazing?
It's a lovely community on
Yeah.
the live stream. It's lovely, yeah.
It was because I've never like done or watched. To be honest, I haven't watched live stream before, so this is very first experience. But I can understand why it's such a great forum to be able to actually teach
Yeah,
people.
it's lovely, and also
And
I
chat as
I feel
well,
like I'm not on my own when I'm doing these live streams anymore either. I'm
Well, exactly.
yeah,
I'm
I'm
quite
just
lonely
with all my
otherwise.
people. Yeah, with the people that are watching it and they're interested in it as well. So you've done those three. Wicked. Move on to the back three.
Uh-huh. No, yeah, exactly. It's nice to think that you can do it with people there as well.
Yeah, definitely. Michael Collins says, what would cause a Class D amp to sound good one min and then sound like shit out of phase the next min? Most likely a snapped inductor or some snapped components on the board there from vibration damage. Vibration damage is probably 80% of my repairs that come in are vibration damage related. So you probably have a poor connection somewhere due to vibration damage. So check that out. Did one of them fall down?
Yeah.
That's okay. Is it the one you're working on next?
Yeah.
Yeah. Okay,
Shall I go to the next one, or do you want...
yeah, you can go to the next
I'll
one.
go to the next
Put
one,
that
and then
one
we'll do
in
that one.
again last.
Yeah.
What would the op amp have on it? Says Hammer Knock. What do you mean? What would it have on it? So the op amp should have. Now op amps need a positive and a negative supply of power. So generally on pins 4 and pins 8, generally this is of 8-pin op amps, you'll most likely have plus 12 and minus 12 or plus 5 and minus 5 volts on pins 4 and pins 8, and that's the power to the op amp. On the other pins you may see various sine waves that are relating to your inputs depending on what the op amp is doing. Hi, is this Xenon company board? Yes, Lokesh, this is a Xenon board, well spotted. This is exactly a Xenon board. How can you test SCV 3000 at 0.5 ohm? Well, all you need is a 0.5 ohm dummy load. So you need some big resistors, some big static resistors, or some old voice coils that you can maybe put in a water tank to keep them cool. And then you just do a bench test, run some power on the amplifier at a static load, and all good job. Okay, so you see here, right, so if you zoom in with your head cam a little bit, let's go up. So here we've actually got a solder bridge. Now this is where the solder is connecting two of those legs together.
Oh,
so that's not ideal.
No.
So see if we can get rid of that with the iron. You can sometimes drag, like you can melt the solder bit and drag it so that the bridge goes away. If it doesn't go away, we might have to use some what do you call it? Solder wire. No, I've got this. What's it called? Solder. Oh Jesus, my brain's gone dead.
The wire.
Wick. Solder wick. Yeah, solder wick. We can use some solder wick to get rid of that.
Okay.
Let's see if I can get rid of that. So, you zoom in there with your head cam. Let's go up a little bit with that. So yeah, let's see. I'm just going to twist the tip a little bit. Sounds a bit weird.
That's better.
Okay, so I'm actually going to use the sucker just a tiny bit, just to try and suck up some of that excess solder that's on the bridge there. Okay, so that's got rid of the bridge, but it's left the solder in the holes, which is looking good. All right, wicked, wicked. So what we're going to do is I'm just going to cut the legs off of all the ones that you've done. There's another bridge here. So there's the two legs are soldered together. That's going to cause problems. That's going to cause the amplifier to explode. So we're going to try and get rid of that. And there we go. That's got rid of that nicely. So that's that bridge disappeared. And just make sure there's no more bridges. Yeah, I think they're good. Looking good. All right, good job. So yeah, you only had 2 solder bridges on your first try, which is very impressive.
Really?
I make solder bridges all day long. I make horrific solder bridges and I don't spot them, and then it causes me lots of problems.
Should we tell that way?
It's just one of the things that comes with repairing amps. You make solder bridges and it's a fucking nightmare, and you forget to check for them, and then you cause problems. And
so literally, does that mean that if you miss one, it's just going to explode?
Well, if you miss one, depending on what you've accidentally connected together, sometimes it might just not work. Okay. Sometimes it will draw current and your power supply will be like, holy shit, what are you doing? And it will turn off. Right. But sometimes it will explode. Sometimes it'll explode. Yeah. Just depends what you've shorted out.
I am really impressed with your eyesight, because like even my glasses, I'm just like so tiny.
Oh shit, yeah, that must be a
thing
with the old glasses and the eyesight.
But like, so you must have literally 20/20 vision.
I don't know. I mean, no, I haven't. One of my eyes, my left eye has astigmatism, which means
Mine's the left as well.
Is it?
Yeah.
My eye is actually a rugby ball oval shape, or what's it? American football.
Yeah.
It's a football shape, a rugby shaped ball. So that means that I'm actually very slightly short-sighted in one eye, but luckily the short-sightedness is quite mild, and the good eye makes up for it.
That's good.
So I see all the detail with the good eye, but I get the depth with the bad eye. Yeah, pretty much. I asked earlier about which O-scope brand is good for a first timer, and I answered that question. HP 54602B is a brilliant scope for a first timer. I highly recommend, and you can pick it up for not that expensive either.
Sam's such a romantic.
Yeah. Absolutely. I'm prepared.
Course,
I'm prepared.
Who wouldn't want this?
Fixing shit. Doing my job for me.
This is basically. To be fair though, wine. That's not a bad start.
Wine, yeah, wine. Just real quick. Get a bit of that solder.
Oh yeah, solder.
Bev, is that moment you power up and it burns a hole in pocket from a bridge? Yeah, that's happened a few times. I have to admit, solder bridges caused me problems in the past. Luckily, I don't think I've had any explosions from solder bridges that I can remember. I've had explosions, but not due to solder bridges.
When you say explosions, but how bad are these explosions?
Have you seen the video of them?
No. What is it like?
Yeah. Boom! Yeah, boom, smoke, like flash. Yeah, pretty bad.
You're right.
Then, yeah, it's fine. It's just a bit like, it makes you jump, and it's like, what the fuck? Yeah.
Yeah, of course.
Yeah. Thank you. I missed it earlier. We need more ladies in repairs. This is quite lovely. Oh, I'm good. I'm glad that people are enjoying this. Yeah, for sure. I do find it interesting actually that repair seems to be very male-dominated oriented, and I wonder why that is.
I get really upset at the fact that it's like that. Because I mean,
yeah.
the weird thing is,
But
though,
it doesn't seem that girls are into it but can't get into it. It seems that actually
we are interested. That's the thing. Like, I think we don't talk about it. Like, for example, so the good thing is that schools now, obviously, like, girls get to do DT and all that stuff. So therefore, you know, I mean, for example, I have soldered before. Years ago, I've soldered, and I really enjoyed doing all that stuff. But yeah, it's just a shame because I think there's this idea that girls wouldn't be interested in this stuff. But actually, like, for example, when we've chatted about what you do, like, I love to understand. I want to know. That's the thing. I don't want to just chat to you about it. Like, I want to actually understand what you're talking about because. And I think a lot of people like that, but maybe people, I don't know. I think I'm lucky because
do you think maybe like some girls might think, oh, that might be pretty interesting because it's like not like socially a thing that girls do.
Yes,
do you think they think, oh, maybe I shouldn't do that?
Well, it makes me really sad to think that that is the case, but maybe
that is a massive shame if that's the case.
The difference is I've realised this. I probably wouldn't ask so much if you weren't my friend. Like if it was somebody I met who did it, I think I'd be a bit embarrassed because maybe I feel a bit inadequate that I didn't really know enough to be able to even have that fundamental conversation. Because it's you, I can just be like, Sam, what is this? What is that? And you're not going to judge me. So yeah, I think everyone.
Modbox says women can fix shit. They're just as smart. I think women are. I actually think women are a bit smarter in a lot of ways. In a lot of ways, I've come across women, very smart women, and their brains work slightly differently, and in some cases, in some problem-solving ways, much better than men's.
Well, no, I think that it's all equal. It's just that I think it's confidence. It's having confidence to actually, for women, perhaps to actually sometimes do the fix. They definitely can. I mean,
iPad rehab, yes.
What's iPad rehab?
iPad rehab. So I watch a guy called Lewis Rossman who does what I do, but does it with Apple MacBooks.
Okay.
He has a. I don't know if he's a friend or business partner or something. Oh no, what's it? I'm pretty sure it's his mother-in-law. Can someone confirm that on me? I'm pretty sure that the iPad Jessa, I think it is. I think they're somehow related, aren't they? Somehow, I think it must be. I think it's his.
That could be the
mother-in-law or something. But yeah, basically, she is an absolute genius goddess at repairing iPhones and smartphones.
That makes me really happy.
Absolutely,
happy.
Yeah, fucking brilliant.
Yeah. I'm really pleased. Okay, that's good. That's such a great thing. Yeah, more women should do this stuff. And also it's nice, like, I'm really lucky, like, Sam is teaching me, because otherwise I wouldn't know.
That's okay. Alright, so, all the new drivers are in, so all the new middlemen are in.
Big question, does it matter, like, the height?
So that one's sticking up a little bit. It doesn't matter, no, at all. The length of the leg isn't really important in this case. It looks neater when it's all down, but it doesn't really matter. No one sees the inside anyway. So, the fact that one, so if we zoom in a little bit on that one. So we've got one driver here that's a little bit taller than the rest of them, but it's not important whatsoever in this case. So what we're going to do now is, you remember before when we looked at the waves, there were some that were really shitty, bad shape.
We're not looking healthy.
Not looking good. So now we've put new middlemen in.
You can check it out.
Hopefully the waves will look nice and good. So we're going to take the purple one here. So we're going to do the same thing that we did a minute ago. So if you put the probe on pin number 1, which is that one there, and we're going to go ahead and look at the scope up there and see what the wave looks like. Okay, now that looks like a sexy looking wave. That was a good wave before.
It was.
Now if we go into the next one. Yeah! So that's looking nice as well. So we're going to go along to the next one. Yeah, looks pretty tasty.
Okay.
Next one again. Yeah. Next one again.
Buddy, it's working.
Next one, yeah. And next one again, yeah. So they're all looking really nice. So let's check the other side as well.
Okay.
Yep, that looks good. Nice and sharp, nice square. Yeah, that looks pretty good.
That's good.
Okay, so I think we can pretty much safely say that changing the drivers there sorted out the issue.
Great. Okay, I'm just going to go along to these final ones and then we're done. Okay, yeah.
Yeah, that looks pretty good, doesn't it?
Okay,
so that's the first part of the repair is these FETs need to be told to drive on and off nice and sharp with a nice sharp square wave. So the fact that we've changed those 4 has made those waves really nice. They look really good. So we're at this point we are safe to put new big strongmen, big MOSFETs in. But just before we do that, in between here and here, there's a resistor. So there's a resistor is like one of fucking one really quickly. So this is a really big one, but basically this is a resistor.
Okay.
So what it does is, rather than things being connected directly together, metal and metal, the resistor causes like a blockage. So if you think of a really thick pipe, like it's basically like a pressure reducer. So let's say you've got a shower in your bathroom and you turn a shower to full, it's fucking way too much water, it's too much pressure, you're emptying your tank really quick, it's too much, it hurts. So what you do is you put a reducer, so you put a really thin bit of pipe in between. So you put a really thin bit of pipe in between, and that then causes a resistance in the path. So it slows it down, and that's what a resistor does. And resistors have different values depending on how much they're slowing the voltage pressure down. And the value is related by codes here. And these stripes, the color denotes numbers. So it'd be like 1, 0, 0, like for example 100 or something like that. So that's how you work out what value these are.
So what would that one be?
I don't know the numbers off the top of my head. I'm really bad at this. I have to check on Google because I don't know. Because this is something that I would have learned if I took electronics classes or I did an electronics degree. I would know these off the back of my hand, these resistor codes. But because I didn't do anything like that, I don't know the resistor codes off the top of my head. I have to Google them.
You could tell me a number, I would be
that's just something that comes with doing a degree in electronics or learning and jumping in the deep end and just learning on the job. I haven't learned. I remember some of the common ones that I use, like 47 ohms has the purple and yellow in it. I know that the 10 ohms and the 1 ohm is the black and orange, black and brown and shit like that. Like, I know some of them, but not all of them. Obviously, I don't know all the codes. Anyway. So, like I said, in between each of these drivers and the outputs, there is a resistor, and it has to be the right number. If it's not the right number, then it's going to cause problems. So, the resistor that's in between each one, if we look on the bottom, is this baby little one here. So, we have a little resistor there. Now, by each in the legs number 1 that we're reading, right next to each number 1 leg, there's a little resistor. So, you got one there, one there, one there, one there, one there, one there. Sometimes those get killed. When the house party goes. So the way to check whether they're dead is to use this multimeter here, and what we're going to do is we're going to read the number across the resistor, and that will tell us whether it's good and good health or not. Now my multimeter is very cheap and it's very broken. As you can see, the leads here are like glued and shit. So when we touch the leads together, we should see 0 on the screen. But because this is a very cheap, crappy multimeter, we actually see 2 or 1. So we need to take that into account when we're reading these numbers. So, yeah. So what we're going to do is take our multimeter here and go either side of the resistor. And so the resistor, this is a good resistor. This is 22 ohms. Which is the correct value for these power supply FETs. Okay. So we just want to make sure that each of these resistors are actually 22 ohms. Okay, that one looks like that one's quite high. 31.
That's roughly
22.
Right.
Okay, so that one is a bit high. So that one needs replacing.
Do we need to give or take, for example, with the first one? You know, when you read without anything, it's about 0.02.
It's like
we need to give that, like, compensate for that. So
yeah, we do. Yeah. So I mean, it depends because these wires are really cheap. Depends like where I hold the wires. If I move it around, sometimes it goes down to 2, sometimes it goes down to 1.
Oh, I see. Okay.
So yeah, you
give or
like,
take 0.01,
yeah.
0.02.
I mean, because I know this circuit really well, I know that these resistors should be 22. So sometimes it will read 22, sometimes it will read 21, 23, 24, etc. Like now it's reading 23, 24. But I know that resistor's fine because I know that this multimeter's crap.
But this one is too high.
But this one, this one's reading like 30, so that's too high, and that's going to cause problems. Even though the wave looks fine, when we put a MOSFET in there, that's not necessarily going to be good. So that one needs changing. Let's try this one. Okay, that one's reading okay. That one's okay. That one's okay.
What's the beast?
I think my wires are very fucked. I think that was probably okay. Or maybe not. I really need to get myself a new multimeter. 26, and the Tesla resistance is 3 or 4. So that's probably fine. Put a tiny amp so she can learn, not the beast. No, you got to jump in the deep end. That's how I learn.
I'm scared.
You got to jump in the deep end. 25. That one's 25. That one's 23. I'm going to say we replace that one. It's a bit different to the rest of them. So we've got 2 on this side that we're going to replace. We're going to place number 2 along. Yeah. Which is this one which is reading 30.
Number 6.
And this one which is reading as 25, 26, 25.
Yeah, yeah.
So let's check the other side. I'm just going to really quickly go along these. Just check these off.
Okay. That's about
23,
right.
that's about right. This one.
That's about
3.
right.
Yeah, that's about right.
Ooh, a bit high.
Yeah, we're going to replace that one.
So which one is
so
that?
That's number 1, 2, 3, 4.
Number 4. And number 6. 4 and 6.
Oh no, that one's alright.
No, that's okay now.
That one's alright.
And
that one's alright. So number 4 here was a little bit high.
Yeah. And number 2 and 6.
Oh no.
This is the thing. How it?
Yeah, it's because my multimeter is really shit. That's probably fine. So I'm gonna say that the only the ones on this side look bad, and the reason that also that backs up the only ones on this side look bad is because the only driver that was burnt out of all 8 of these, the driver on this side, the PNP, had some blackening on the board here, so this side got hit worse than this side. So if any gate resistors are going to be dead, it's going to be any of the ones on this side. So probably just as a precaution, it might be a good idea just to change all of the resistors on this side. So we've got 30 on that one, and what was the other one?
About 20. What was it?
Yeah, so that's both on number 2 over here. That was bad. Yeah. Okay. So we're going to replace those real quick. Bevid, you're the middleman in teaching today. Nothing wrong with that. Huh?
I don't
get that comment.
I think it's a compliment. It's a great compliment.
I think it's a compliment.
It's a great compliment.
You two so cute working together. Thank you very much, Drabara. Thank you very much. Poking fun at your meter, the buzzer is super loud. Yeah, it's a good loud buzzer though. It needs to be loud because I listen to drum and bass when I'm doing repairs, usually when I'm not on live stream, so I need to be able to hear the buzzer above the music. What is the best way fix shorted inductor? Dip it in epoxy resin. To fix a shorted inductor, what you have to do is you have to actually pretty much unwind it. So you have to find the short, so locate where is the short, so you pull it all back, and then you can usually see where the short is, and then use some use some Tesa tape, Tesa tape, to isolate the short on there, or you can dip it in epoxy resin. That's probably not a bad idea either. You want to just insulate the short on the cable there, so it's not making a short circuit. Now, if it's shorting to the core, that's a problem. You can dip the core in epoxy resin, or you can wrap the core in Tesa tape and then rewrap the wire around it, making sure that you insulate the breaks on the wire itself. Heat shrink works well. Yeah, heat shrink could probably be alright as well, as long as it's nice and thin. Okay, cool. So that's it was number 1. Let's just replace all these ones on this side. But we're going to replace all 3 of the ones on number 2 because that was the ones that died. So we're going to replace 2, 4, and 6.
Okay.
So flip it over. So we take our soldering iron, and I think what we can do is probably use the thin tip on this time.
I'm definitely wishing you to this best. I'm really scared of these. These are tiny.
They're pretty big. Well, they're small. You wait till we get to,
oh my gosh,
to something.
Sam.
Ow.
You're right.
That just look weird.
Sam, careful.
Yeah, it's a good job we're not repairing a Brazilian board because that would be very, very small parts.
Oh
yeah, very small parts. So that was 1, wasn't it? So we've got 2. Yeah. So what we're going to do is we just want to heat that up like that. Keep your hair still. There we go. So you heat that up like that and use the sucker. Suck will solder out the hole. And we can use the tip here just to bend the leg up so that it's nice and straight. So that when we pull it out, it comes out nicely. There we go. So that's nice and straight now, so it's going to come out nicely. And do the same on this one. There we go. So that's all now loose. So you can just pull that out with tweezers from the other side. So it's 2. Four and 6, which is this one here. Just move them around so nice and loose in the holes. It should come out nice and easy with tweezers. So put the board back over. Perhaps electrical. I actually hate electrical tape. I think it's rubbish. It doesn't stick. It comes off fucking easy, and yeah, it comes loose from heat over time, as Modbox says. Really crappy stuff. I don't like electrical tape. I'd much prefer tester tape. It works brilliantly for insulating wires and stuff like that. Much better stuff. Okay, so yeah, those resistors that we just did, we should be able to take some tweezers. Which where did I put the?
They were here.
They're here. And they're number 2 here. So we should be able to pull that up like this. Pull it out. There we go. So you can see that's actually looking pretty blackened.
So yeah, that really.
So if you get the camera on there. So that that resistor actually looks pretty burnt there. Yeah. So yeah, that's definitely a telltale sign that one's not looking too good. This one was reading fine, but we're going to replace it anyway because we're replacing all 3 in the same.
I wonder if you can see the difference, like between.
Yeah, you can see the difference for sure.
Oh yeah.
You put those 2 like that.
Definitely see the difference there.
Yeah, one of them's looking pretty burnt there. The other one's actually looking pretty healthy.
Yeah.
Yeah.
It's good to be able to compare.
And then this last one over here. This one again has some black on it.
Oh yeah, you can see yourself.
Pretty black on that one, yeah.
Brains.
So we're gonna go in my drawers here, magic drawers, and we're gonna find some replacement 22 ohms, which I do have somewhere. Oops. Okay. So we need 3 of these. So there's one there, 1, 2, and 3. There we go. So what we do with these is just slot them into the holes. It doesn't matter which way around they go, because they're non-directional, so they can go either way around. Doesn't matter.
Where are they going again? Sorry.
So there's 2 little holes here from the resistor that we moved. Yep. So pop it in hole number 1 and hole number 2. There we go.
Oh, you gotta have like really good dexterity, like for this stuff. It's like very fiddly. I wish I'd taken electronics.
Oh really? You're finding this intriguing? Or?
Yeah, so I do graphics, but I think electronics is really important to be able to do.
Akisi says, what soldering iron are you using? I'm using a AOUA 2738A+. 2738A+ from AOUA. It's not a very good soldering iron. I don't recommend it. You can get much better, but this one came really cheaply for me, and it works for what I'm using for at the moment. So, yeah, it does okay. Can you get it in there? Not going in, is it? No, nearly. Let's have a look.
Just doesn't want to go that way.
Maybe there's some solder on there.
There's some solder trapping.
Possibly. Oh no, there we go.
Did it go?
Yeah, it's in.
Okay.
There we go. So you can see now, yeah, it's pulling there nicely.
That's
And we can actually solder this from the top of the board. We don't have to go to the bottom.
Can you?
Yeah, because the hole is just the same either side. The only reason we do it from the bottom before is it's easier to get the soldering on with the resistor in the way. But Matt Fields sends us $5. Thank you very much, Matt.
Oh, thank you.
100% agree. We should learn to fix stuff instead of throwing it
Yeah.
away. Silicon tape is amazing stuff. For high power, heat only adheres to itself. That's interesting. I'll definitely check that stuff out, Matt. Thank you very much for the kind donation and also the advice there with silicon tape. I'll definitely check that out.
Okay, I'm gonna give you
Can I see the face of your student? It's nice to know who I'm listening to. Yeah, I'll change the cameras around in a minute and we'll have a look at Ashley's face.
It's not,
We'll take the hat off because the hat is. I have to say, the hat's very useful for the camera. It's not doing it many favors though. It's
What do you mean,
it's
Sam?
not. No, it's a really gross
Please.
hat. It's
I
like
was trying to rock this.
I look
style,
really
just
bad
so
with the
you
hat. I look bad with the hat. The hat's a gross
Don't
hat.
don't lie. You rock a baseball hat.
Yeah, but not this
You'll
one.
say like that.
This one's a gross one. Hence why I duct tape a camera to it.
Okay, I can't. I'm so bad at this. Right, 1 minute. Let's see what this is.
Yeah, definitely don't need the best iron in the world. You just need something that gets hot quickly, gets hot enough, and you know how it works. That's the important thing. The AOUA temperature gauge is not accurate by any means, but I know what numbers correspond to what works on different boards, if that makes sense. So I'm not really using it to get the temperature. I'm just kind of using the temperature gauge as a kind of just as my own gauge to work out how hot something needs to be for different types of sections on the board, really. Yeah, as long as you know how hot it should get. Is you struggling with that one?
Yeah.
Okay, let's have a go. So let's see. So try and get them so they're both going at the same time, and put that one there and that one there, and then we just line them up and whoop, pull it through like that.
Make it look so easy. This one's got a little kink in it.
There's a kinky one.
Kinky.
Nothing wrong with a kinky.
There's nothing wrong with kinky.
I tell you what we can do, because that's going to be
Can we
difficult. We
snap
can cut that kink off.
Yeah.
Yeah. Now this one actually has a leg left in the hole because I didn't actually snap the leg off. But I wonder if it's going to go next to it. Yeah, it will. Yeah, that's fine. Push it through like that. Alright, cool. So that's 3 new gate resistors. These are gate resistors. So we're going to heat the soldering on up again. Get this thing soldered in. Let's move these pedals in like that. There we go. So we're tag team this. If you want to get the solder.
Oh, I need some more in it.
Okay, and if so what I'm going to do is I'm going to hold the iron tip on this hole. So if you just put some solder on the tip, and then you see it soaks into the hole.
Okay.
Really cool. There we go, nicely done. I'm going to pull the trim switch off the back because it's kind of in the way. And we're going to do the same to this one. Looking good, yep. Don't need a lot, just a little bit. Soaks into the hole, perfect. And let's do this one there. Come at it from the, oh, careful of your little finger on the iron. Come at it from this angle here.
Okay.
There we go. Okay. Should be enough. It should soak in a minute. Go on a little more. That's it. There we go. And okay, that's good. No, that's enough. By the way, I asked you on a high pass filter error on a Gladen amp. It was the switch. Ah, the switch. I've had switch issues before with Orion amplifiers. Yeah, this, and also I've had actually switch issues on many amplifiers. So I'm glad you found it. It's not that common, but it can happen. There you go. Just and this one there. Okay. A tiny bit more. Yeah, perfect. Okay, great. So that's the gate resistors all soldered in. So we're going to flip the board over, cut the legs off. So let's trim these little legs off here. Okay, great. So now, wow, what's going on there?
Oh.
So now we're ready to fit some new MOSFETs, but as you can see, all the old legs are in the way.
Yeah.
So we're going to get rid of the old legs, and to do that, I'm going to change my soldering iron tip out for the thicker one, so we can get a bit more heat going on.
Mm.
So to remove these tips, what we're going to do is take our tweezers. Maybe the thicker tweezers would be good if I can find where I put those. I might not be able to find them. Oh wait, there we go. There we go. So we're going to take some thick tweezers, and what we're going to do is heat up. Let's turn the heat up a little bit. We're going to go for about 416 degrees on the soldering iron. We're going to heat up these legs here. Okay, so you see the solder melts, then they come wobbly. When they're wobbly, you push them down, and then collect them, put them through from the other side.
Can you not pull them through upwards?
You can, but it's getting difficult because when you try and pull them through upwards, your tweezers end up pushing them down. So we can try that. So if we put the camera to that one, so we can try and pull it from this side, but sometimes it works. Sometimes the tweezers pull them down. So that one, ow, kind of works, but it's difficult because there's always a thick bit on the tip. So it's better to do that. Heat it up from this side. Let's pull the cap up. It's better to heat it from this side, push it down under, then grab it from the other side, like that, and it comes out like that. So we give that a go. Well, I'm going to be here with the extra solder because sometimes it makes it easier to soak her up with a bit of extra solder with some flux in to get it all there. There you go. Hold the iron on there. Bit of extra solder. There we go. So get some surface area. So twist this. So you want to hold this on there for as long as possible. Get some surface area. You can see it's nice and melted now. So now hold that there. Hold that iron on there, and then go and grab the thing. No, keep the iron holding. You keep it all times. Keep it on there all the time. Yeah. Is it? That's it. Nearly. You just need to grab it. So you need to pull this back a little bit. So you are tweezing it. There you go.
Is it?
No. Okay.
Actually, you can see the angle there. Yeah.
There we go.
Okay. Let's try the next one.
Yeah, so you can grab it. You can grab it first.
Yeah.
Have a look first and grab it first. There we go, nicely done.
Thank you.
Bevis, open up that iron control box to adjust the heat. Yeah, if it's got an LCD, there's an input command to adjust the actual temp. A DMM thermocouple is accurate enough for the job. Really interesting info. Thank you very much to Matt Fields. Again, great with the info, Matt. Great for the info. Yeah, Matt's given us some really good advice. It may sound a bit weird, but I find it strangely relaxing watching you work on amps. Good, I'm glad.
That's nice.
I'm glad that you find it relaxing. I find it mostly relaxing working on amps, and until they start exploding, then it's not relaxing. Or if I've got a customer that needs the amplifier to be fixed by like the next day and it's not going well, then that's not relaxing. But yeah, most of the time it's relaxing.
Sam, this one is just not good.
A girl that knows how to solder. I didn't think it would be possible. Of course it's possible.
Of course it is.
It's a human skill.
What do you think?
It's like saying, oh my god, a girl that knows how to walk.
Oh, exactly. Because girls. Okay, as I say that though, I am.
No, yeah. Well, this is the first time that Ashley's been doing any soldering in a long time. I could not solder for absolute shit when I started doing this. I was the worst solderer in the world.
This one is not like.
No, we need a bit of extra solder on there just to. Okay, there we go. So it makes life much easier, isn't it? So what you can do is, obviously if you had 3 hands, you can do this, but
that makes such a difference. Like,
it's crazy, isn't it?
I wasn't expecting it to be so.
It's so much easier with a bit of extra solder.
Yeah.
Just freshens it up.
Oh my gosh, it makes it literal.
Really?
So quick to just take it out. And
yeah.
Got a bit of that.
Oh.
Sorry. Did I get you?
It went in my shoe. So that bit of hot solder just went in my shoe. And I haven't got any socks on either, so that was pretty interesting.
I'm so sorry.
That's alright.
Okay, yeah, that's how you don't solder, is don't get your friend with it. For sure.
That was nice and hot. A nice little sharp wake up call in my foot. Yeah.
Just making sure you're awake. You're alright.
Yeah, just trying to get my shoe back on now.
See, now Sam's regretting asking me to come in and help out.
Sorry. I've worn shorts in the workshop before, and that was not a good idea because hot solder flies on the shorts, and that's not nice.
No. So Sam, I have a question.
If
there isn't a third person, or second person available to give a third hand, how are you?
I go round and I put fresh solder on all them first, and then use the tweezers.
Okay,
Just
that
takes
makes
longer.
yeah. That makes sense. Yeah,
Keeping my
sorry.
feet well out of the way.
I'm so sorry.
These thick ones are hard, so you have to keep the soldering on for a little bit longer. So you just keep. That's it. Nice. That's it. She's doing really good, guys. She's doing fucking really good. She's doing really good. She's doing really well.
Apart from like the
No, she's doing really well. That probably would have happened by myself anyway.
No.
Yeah, I've done all sorts.
What's the worst you've done? Like,
I gripped the soldering on like a pencil once.
did you break your whole hand?
Yeah, I burnt my fingers. Yeah.
Man, that sounds painful. I've done that though, like when I've been cooking and I picked up a tray from the oven and I just didn't wear any oven gloves and I just went for it.
Yeah.
That was really stupid of me.
There we go. Last one on this side.
Okay. Oh, yeah, I just did that too. I picked up 2 pens.
Oh, no.
Sorry.
You shouldn't have to pour hard. It should literally fall out just with a tiny bit of force.
Yeah.
Yeah. If you're having to pour and it's not melted enough, so wait for it to melt and then it should just fall out in your hand. There we go. Like that. Yeah. Perfect.
Beautiful. I was gonna say your viewers are like really patient to like watch. Do you know what I mean? The time that's spent to take it. Very patient.
Yeah. So I'm just going to really quickly do the other side.
Because
the other side, I don't think I can flip the amp around how I want to. So just going to very quickly do these ones.
Yeah.
I might need to actually. Actually, let's get some solder. I'm going to do these ones from the top board because the wires that are plugged into the car supply, they got short. They don't reach at the other side anymore. So I'm just going to apply some fresh solder to this side. 4 of these. Let's put that down and get the fumes.
Greg says hey. Hello. Also,
Greg Fagan, yeah, Greg Fagan. Good evening, my friend. I just missed you at the bus the other night. Actually, I turned up about 5-10 minutes after you left. I sat with Janti and Sam, and I think Adam just left not long ago as well. I think Adam was there. But yeah, Greg, how's it going, man? I hope you're well. Teaching my friend Ashley here how to repair an amplifier. It's been a very funny live stream so far.
it's cool.
Now we're going to move on to the output section in a minute.
Hey Charles from Petros, Tennessee.
Tennessee, good evening.
Wow.
Good evening. Yo, it's Greg Fagan in the chat room. Big subscriber too. Cool. Greg, you got some fans on here as well, my man. Wicked.
How do you know Greg? Like this Greg?
I know Greg through the UK bass scene. Greg's a really good friend. He's had some really loud cars. Yeah, he's pretty big on Instagram and stuff with the cars. He's really big demo monster.
Yeah. Oh, awesome! This one's so cool. It's like your Irish accent.
Yeah, these two are like folded over each other.
Ah.
They're like hugging and they won't want to let go.
Ah.
There we go. That's what going on in the chat. You can't change the PSU and Pro Audio amps. No, you can't. Girls can't do this. Girls can't do that. My mum was on the mixing desk for live band around the time. She had me in early 20s. That's fucking wicked, man. Nice one, Ruth.
Your mum is super
That's
cool.
Watch your stuff all the time. I've heard of. Have you heard of LOT instead of lithium? LOT. I haven't personally. That sounds pretty interesting though. I might do a bit of research on that. I see she's doing good. I like the idea of special guests. Yeah, special guest stuff. Pretty fun. Yeah,
I tried to say to Sam to get his mum and dad to come in to do the special ones.
Oh, I don't know about that.
I think they should. I think that'd be awesome. Hey, Timothy.
At the moment, this is the boring part because this is the part where I'm just removing all the dead legs from the old FETs. So we looked at the drive circuit earlier, and we found the drive circuit was very bad, some pretty bad looking square waves on the drive circuit. So we replaced the drive circuit, or actually replaced the drive circuit.
You did most of it.
No, actually replaced the drive circuit pretty much. She probed all the waves, and she saw that the waves were looking bad. So she thought, we should replace those drive chips, those drive transistors. So she replaced those drive transistors, and now the waves are looking damn sexy. And so now she said to me, "Oh, Sam, we can fit some power supply MOSFETs now."
I did. I did exactly that.
And so that's what we're doing. We're now fitting some power supply MOSFETs, and we've also changed the gate resistors. Because a couple of those were reading out of tolerance. So yeah, she's doing really well.
Aw, cheers, bud.
Really well.
I'm currently just watching you. Bless you.
Yeah, just because this is a bit of a
this one looks
bitch.
tricky.
From the top board is a bit annoying. I hate doing top board stuff.
I was going to say, like, that's, gosh, jeez. Don't know how you do that.
Some of the amplifiers that I repaired at Modified Nationals, I didn't bother taking the amplifier out of the case.
Really?
Yeah, because it didn't have time. So you just have to do all this crazy stuff from the top board, changing the FETs and stuff. Yeah, it's not easy, but luckily I had lots of sunshine, so I could see what I was doing.
Yeah.
That was useful.
Gosh, this is really intricate stuff as well. So to be able to do that when it's all still fitted in the casing, is incredible.
Okay, so that's all those fitted. So now that we've removed all of the dead MOSFET legs, what we've got to do now is we've got to go ahead and suck all the solder from the holes. So this is pretty boring stuff, so I'm just going to do this real quick. So we just heat up the pad, heat up all the solder that's left in the hole, and then take the solder sucker from underneath, suck it through, and it leaves a nice hole in there. Let's move your camera up a little bit. That's all right. There we go. I don't know, it's too high. This is tricky to get right, this camera.
My head's just a weird shape.
Timothy Webb, what are you working on? The amplifier is on the screen. It's a generic Korean 4.5K from Zenon factory.
What is the creme de la creme of like amps? If you had to
I mean, from what I've worked on, the JL Audio amplifiers seem to have some of the best design circuitry that I've seen. Yeah, phenomenal circuit design from JL Audio.
Does it just mean it's easy to work with, easy to repair?
It's not necessarily easy to repair, but from an audio sense, like, you know, and when you're running a subwoofer on the amplifier, you're getting really good power for the size of the amplifier. You're getting a nice quality of sound as well. Yeah. Yeah, the JL Audios have very clever circuitry that for people on the live stream, they negate box rise kind of. They negate the impedance rise to some extent. So the JL Audio amplifiers, the old Slash series, they do the same power from 1 ohm to 4 ohm, and they also do the same power from about 9 volts to 14 volts. So voltage drop, it won't change in power, it just has more current demand from the system at lower voltages. And if your subwoofers are high efficiency, then the amplifier will make best use of that because it is able to provide good power at a higher impedance as well as a lower impedance. So yeah, very good amplifiers. If you run a JL Audio 500/1, it'll feel like a much more powerful amplifier than it actually is, because it's able to do the power at a higher impedance after the rise of your woofer. They're very cool amplifiers. This is the boring stuff. This stuff takes the longest and it's the really boring. It's just sucking the hose. Okay, that's that side done. We'll do the other side. Get that out of the way. What's that core around there?
Yeah, that's okay. Let me just move that way.
So you give this one a go. So hold the iron on the pad till the solder goes all melty. Hold this in the other hand. So you wanna sort of with this you wanna put like some surface area. So you put it this way round. So hold it on the edge so you can see when it starts to go all watery like that. And then take this, put it underneath the board, roughly whereabouts there, and then push kind of up a bit so it makes it airtight seal and push the button. Oh look, there you go.
Okay, nice.
Made a nice hole.
Sweet.
So do you want to try it with this?
I just don't know if my dexterity, like, do you mean where I can do both at the same time? Let me give it a go.
Yeah, it's very it does very quickly. Yeah.
It does. Right.
What do you think of Sundown Audio SCV range of amplifiers? Yeah, they're good amplifiers, but they are very generic circuit designs. They're nothing special. It's the same shit that's in DC Audio, SPL Dynamics, Ground Zero, Digital Designs, etc, etc. It's nothing special. They are, however, a very good build quality, and they are very polished board circuit designs. So they're very reliable, but from a sort of what's the word? Ingenuity kind of sense, they're nothing special. They're just very generic, same as everything, same old bullshit. Yeah. Nothing special.
So you're not a big fan then?
Yeah, they're fine amplifiers, but I like amplifiers that, you know, the company's actually designed their own board from scratch and actually come up with something pretty cool like JL Audio has, and Rockford Fosgate, Alpine, for example. Alpine actually make bloody brilliant amplifiers. Alpine don't get enough credit for their amplifiers. They make really good stuff. Dave's Con says, it's not my first amp, it's only that everything seems fine, but then when you plug it in, something different explodes almost each time. Oh damn, that's a massive headache, man. Every time something blows, I find more problems following the traces. That amplifier is gonna teach you a lot about amp repair. Yeah, it might be a headache now, but that amplifier is gonna teach you a lot about amp repair. So yeah, just pull that out, that shit, yeah, there we go.
Yeah, it'd be good to be able to, the best way to kind of learn, I suppose.
Yeah, the best way to learn is to dive in the deep end with something that's a real headache. And if you can fix it, then obviously you learn a lot from that. That's more wine.
Yeah.
I'm going to go grab some more wine while actually sorts the rest of these holes out.
Okay, it's going to take me a little while, so let's just try. What type of wine you guys?
Probably the red.
Yeah. Sounds awesome. Okay. Sorry guys, this is taking me a little while. I'm not very good at this. Right. Thank you.
So yeah, there wasn't any wine left, so I got some
It's alright.
a little cocktail.
Yay! Oh, nice.
A little cocktail.
Okay, so I think this is like, I've plugged this up, so I'm just gonna.
Oh really?
Yeah, it's just not working as tight. You have done something. Oh, 1 minute, actually, that's just come out there. Maybe that's better.
So what's there? Is it the last one here?
It's these, yeah. I actually think that solder came out, so hopefully it might be a little bit better.
Okay, let's have a look at what's going on live chat real quick.
Yeah, of course.
Let's see.
This one is not open.
Bevis, how's your car coming along? I really want to see those T-lines completed. So the car isn't in any future state, in any progressed state since you last saw it. So the guy who's working on it, Henry from Hard Acoustics, has been very busy, but he will be working on it very soon, sometime this month. So I'll do some videos once that's been updated. All amps can be repaired. There's many sellers in the US that sell, manufacture, refurbish, same thing. Pretty much the same thing I'm doing. Yeah, absolutely. So what do you recommend for 3K instead of the STV range? Well, that's the thing. It depends where you live. I mean, like, I'm not saying the Sundown's a bad amplifier. It's a very good amplifier. So yeah, absolutely. If you can get your hands on one, then go for it. I'm just saying in terms of like what I would perceive as like, hell yeah, man, that's a sick amplifier. Like, well done. That's a really good design. They're not. They're just a generic design, but they're very good. So if you can get your hands on one, then go for it. Okay, let's get these few last ones real quick.
Is it blocked in there?
No, I don't think so. Let's have a look. So this one here.
Yeah. Okay.
Look up a little bit. Make sure the holes are nice and big, so that the new FETs will go in nicely. Yeah, it looks pretty good. Looks like you did a pretty good job. Yeah, let's see that one there.
Yeah, that one's better.
Got a little bit of...
Yeah.
No, still a... I think this is one I missed this side. Okay, cool. Yeah, looks good. Alright. So now we're going to go ahead and fit some new FETs.
Okay, nice.
So this is the power supply section, pretty much almost fully repaired. So let's flip the board over. Oh, what do you think of the drink, by the way?
Really nice.
Is it okay?
Yeah, it's gonna. I was about to comment. I thought we were going to say something. I was like, I won't interrupt about drink. It's very nice. What is it?
It's actually a rum and lemonade, so it's the only things we had left in the house.
But it works really well. It's nice.
Yeah, it's not bad, is it? It's okay. Pretty much no wine left in the house. We had no Coca-Cola.
I cannot believe you have
we
no
had
wine
no
left in your house.
Disaronno. We have got wine left in the house, but it's a 26-year-old.
Oh yeah, no, don't do that.
Yeah, it's very expensive. I'm not going to drink that tonight.
Yeah, no, fair.
So yeah, okay.
Okay.
So new MOSFETs then for this amplifier. Now this amplifier uses IRFP064Ns and a power supply, but I don't have any of those. I have some upgrades. So we're going to put some slightly better FETs in the output section here, and the output section, power supply section. I'm going to use some IRFP 1405s. Now these are the FETs which all of the newer Xenon boards are using. All the full bridge boards like the Vibe and the DS18 boards are using. And also the B2 amplifiers are using 1405s in the power supply section. So I'm going to use some of these ones. These aren't the best ones you can use. You can use even better ones, but they can start getting really expensive and it's not really needed in this case. So yeah, we're just going to slot some 1405s in the board like this. So we want to make sure that they line up nicely. So we're just going to push them down into the board just a little bit like that and bend them over, and because these mount to the heatsink like this. So we need to, let's get the camera on. Yeah, so these mount to the heatsink flat like this. So we want to make sure that there's enough of a gap between the board and the FET here, and so that they're sitting nice and flush. They're ready for the heatsink. So let's put this one in next and bend it over a little bit like that. I'm just going to go along and whack these in. Okay, there we go. Oops. A little bit stiff. What happens with Maxsonics Harmonics crunch amps? They seem like everyone only does half is rated now. Yeah, absolutely. Well, unfortunately, as with many really good brand names from back in the day, the name got bought out by some bullshit company, and sadly now those amplifiers, yeah, they pretty much only do half the rated power. It's the same story with Phoenix Gold. Whoa! Look at this. Ah. We have some vibration damage, guys. Okay, so check this out. So, like I say, vibration damage causes a majority of amplifier failures. So it looks like in this case, now this is one of the leads that goes from the power supply transformer over here. This power supply transformer, and it goes to the rectifier. Now this looks like it's actually snapped off there. So, yeah, it looks like we've got some vibration damage that's actually snapped that lead out of the rectifier area here. That's possibly what caused. Well, no, I wouldn't have said that was what causes amplifiers to go down initially, because we've got output section failures. So, but that's just another thing that we need to repair then here. But that's not a big deal. We can easily repair that.
You just literally solder.
Yeah, we can just trim some of this wire off. Yeah. Like free up that hole, put that in there, apply some fresh solder, nice and easy. That's not too difficult to repair. But yeah, it's just interesting. Something else that we've got to do. It's not a problem at all. So just put these FETs in here.
A little bit of a tight fit.
A little bit of a tight fit on that one, but it's not a problem. Just push it down. So the solder, if there's a little bit of excess solder left on the hole, it's actually quite soft. So if you put some pressure and you give it a wiggle, then you can pretty much bend the solder up into the shape that you need to push the FET in, and it's fine. Can I recommend a good value 3-way active car crossover? Head unit. Head unit is the best way. Alpine CDA 9855R.
How do you remember that?
I don't know. I know all the codes.
All these numbers and
all the codes and numbers.
You guys are all on it, and I have no idea what these mean.
No, that's the thing. Unless you're into it, you never know. it's like brand names or like car names. Like for example, you did all the research on all the sciencey stuff, all the so you know all the crazy scientific words for all these chemicals or like cells and stuff. Like I haven't got a clue about that. It's just whatever you're into. You learn the terminology for whatever you're doing. Okay, cool. So we've pushed all those fits in. I did that because we had to wiggle some of those in pretty hard. So
are you saying I'm not strong enough, Sam?
Turn that over.
Okay.
Oh no, not at all. Not at all. Not
I'm
at all.
joking. I'm joking.
It's just a bit of a knack to it sometimes. Yeah. Okay. So we're on.
And I
fresh solder. And have a sip of drink before you do this.
Okay. Right.
Drinks go.
Do you want to do that additionally?
That's it. Put a little bit more on there.
Okay,
Yeah. Load her up.
Well, quite a lot.
There we go.
Is that enough?
Yeah, that's a good mound. You want a good mound.
I feel like the terms you use are like funny.
Good job. Looking good so far, yeah.
There is something weirdly therapeutic about soldering, isn't there?
It is, yeah. It's seeing all that nicely melted solder just fall wonderfully into place. It is very satisfying. A bit more. Because what you want to do is you want the solder to seep through to the other side as well. Okay. So you want to put some solder and then hold the iron on for a bit longer so that it heats and then let go. Okay. And it sort of sinks through to the other side with all the heat.
Do you want me to redo some of the others? Because I think I've been a little bit.
We can have a look from the top. If any of them are missing the solder from the top, we can do it from the top. Yeah, that's good. Pioneer ATPRS badass too. The only thing that I don't like about the ATPRS is that the time alignment feature, you have to set a driving position. Now, obviously, you're going to be using this in a car predominantly. But if you're not using it in a car, if you want to set the time alignment to set up some kind of bedroom system, like or something, then it's not ideal because you want to set the time alignment to the same for either side, and you can't do that. And also the EQ graphs on the ATPRS are nowhere near as nice to look at and as easy to use. And the same for the crossover graphs, are nowhere near as easy to use as they are on the 9855R. The 9855R is a wonderful piece of kit. Highly recommended. It's old school, it doesn't have Bluetooth or anything, but if you want really good crossover points and really good time alignment, it's one of the best units you can get. So now this amplifier that Ashley's repairing here for me, I'm actually going to be using this in the van once it's up and running.
Really?
Yeah.
Sweet.
This will be being used in my van. Yeah, hopefully we do a good job and it doesn't. Yeah, it's gonna be nice and reliable.
Fingers crossed.
Yeah, I'm sure it will. Yeah, it looks like they've done a really good job there.
Do you want me to do some extra soldering?
You could do a little bit extra on these ones, yeah.
Is that the drink?
That's my drink. My drink on the. My drink on the. As soon as I put this on here, it vibrates like crazy. So. Are there any that I can actively three-way cross over the front stage while providing a single high phase rear speaker level output? What do you mean high phase, buddy? What do you mean by that?
Okay.
Wicked. So now do the other ones on the other side. Let's go ahead and do these ones as well.
Yeah.
This is really cool. It's going quite well. Oh, high pass. Are there any that can actively three-way crossover on the front stage while providing single high pass rear? So the no, the three-way active uses. So when you turn the head unit onto three-way active mode, it doesn't become front rear subwoofer anymore. It becomes 1, 2, 3. It becomes high, mid, low. So it's not front rear sub. It's high, mid, low. So your three ways of active are your high, mid, and low. That's your three ways. So you can't then have a fourth rear speaker output. That doesn't exist. That would be four-way. The only way you can do that is if you have a DSP processor with 8 channels of output. Then you can do that. But that gets pretty expensive.
How expensive are we talking?
About 450 quid. Yeah, the Pioneer ATPRS, if you're using it in a vehicle, is definitely one of the best units you can get for the money. Like Matt says here in the chat, it has every feature you're going to need pretty much from a single DIN unit in terms of audio. It's a high quality preamplifier. It's got the Bluetooth built in to a pretty high standard, high quality standard. It's got your time alignment settings, it's got your crossover settings in there, everything you're going to need. Yeah, it's a really nice piece of kit. There we go. Yeah, looking good. Looking good, Ash. Done a really good job. Yeah.
Right.
Okay, that's pretty good. So let's flip the board. Oh, let's flip the board over. And let's see it from the other side. Make sure that the solder looks good from the other side. Put it down nice and safe. Over here.
Yeah. Where's the best way? Yeah, pick it up like that.
Yeah.
Okay. I think I need some more solder.
No, they're looking good, you know.
Really?
Yeah. Yeah, this all seeped through from the other side. Yeah, it looks really good.
Okay.
Good job. Nice one. Alright, cool. So the power supply should technically be fully repaired now. But we can't turn the power supply on just yet. And the reason that we can't turn the power supply on just yet is because the output section still has problems. So the power supply section is going to power the output section. So first of all, we've got this janky bit of flexi wire here sitting around. So we can't do that just yet. And we can't turn the amplifier on yet either because the output section still has some dead FETs. So we risk damaging the power supply section if we try and turn it on whilst we've got dead FETs in the output section. Now, we've got dead FETs in the output section. Not all of the FETs in the output section are dead. So we don't want to cut them all off like we did with the power supply because some of them are still fine. We can salvage them, I can use them in my own amplifiers in the future, or we can reuse some of the batches here. So we don't necessarily need to cut all of those off. What we do need to do, however, is we do need to remove the ones that are shorted so we can power the amplifier up. Do you want to have some of that?
Yeah.
So, there's a couple of ways we can approach the output section here. The best easiest way really is to remove all of the output FETs, so we can power the power supply up and we can read the drive waves just like we did on the power supply on the output section to make sure that the drive circuit is all working well. However, if only one bank of output FETs are dead, then it's not necessarily time effective to remove all of them, which are good, just to check the drive waves on the one that was bad. Sometimes you just have to remove the ones that were bad, fit new FETs, and hope and pray the drive circuit worked. And you can test that before you power it up with a multimeter to some extent. And then you power it up and you see how bad the drive circuit is by the drive waves that you see. And if you're using a low current supply, if there are any terrible problems with the drive circuit, then it'll draw excessive current, your power supply will turn off, and that will give you a chance to find out what was going on. So let's take a look at the output section again then. So we had some shorted FETs here, which I actually found earlier. So we've got get this wire. So we've got one shorted FET here by the looks of things. We've got a 10 ohm resistor there. So we can go ahead and snap this one off nice and quick.
Okay, so you just wiggle it again.
Yeah, just wiggle it again and take that off like that. So now the short circuit on the board has gone away. So we can check this one. This one seems okay. This one seems okay. This one seems so. It's possible that we only had one dead FET in this bank. So by wiggling that and removing it, that's actually got rid of the short circuit on this bank completely, potentially. Now these FETs could still be damaged. They could not be showing a short circuit, but they could still be damaged, and they're no longer MOSFETs. They're now just diodes. But we'll find that out when we go to power the board up. So let's check the other banks for short circuits. So we're going to go ahead and just check along. Whoops. We need to get that because this wire is. These test leads are absolutely dead. I have ordered some new test leads off Amazon, they haven't come yet. So let's do that. Okay, so we're going to test these for short circuits. So we have a short on this bank as well. Okay, so we're going to find the MOSFET that's dead on this bank. It's probably going to be one of these. Okay, interesting.
Okay.
So there's a short circuit across the source and drain of this output FET. But we don't know which one it is that's dead just now. So we can look at the numbers on the screen, and whichever FET has the lowest numbers on the screen is probably the one that's dead. So we've got 965, 950, but it could be on the other side. I think the dead FET, although there's a short circuit between drain and source here, I think that the issue is on the other side, because none of the gates, if the FET is dead, then usually it shorts the gate, which is pin number 1 to pin number 3. None of these have shorts from pin number 1 to pin number 3. So I think that the issue is probably on the other side of the board, and it's just causing a short across the rail. So if we check the ones on this side of the board, so we still have a short on the rail there. Okay, that's really interesting. So we don't have a short on the gate there. So none of these FETs have shorted the gate out, and that's quite difficult to find the dead FET. Okay, interesting. Right, so we've got, on the multimeter there, we've got 708 on that one, 711 on that one, 677 on that one, 712 on that one. So the one that's different is this one. So I'm going to go ahead and take a guess and say that this one is the one that's actually dead. So we're going to snap this one off, and we're going to see whether the short circuit across the rail goes away once we've snapped this one off. Yeah, okay. So the short circuit across the rail has disappeared now that we've snapped this one off. So let's check this FET. There we go. This is the one that was shorted. So by using the multimeter and comparing the numbers on the multimeter, we can find the one FET that's different to the rest of them, and therefore we can find the one that had the short across the rails. So the rest of these should all now be the same. So we now have 980, sorry, 953 on these ones. 953, and let's check these ones here. 722, 722, 720, 720, 720. Okay, these ones all look alright. So it looks like that perhaps there was just a couple of dead FETs on the output section here. So I think the drive circuit's going to be okay. So on this side, I'm just going to go ahead and check this side. 580.
What are you expecting? What is normal?
580. For these MOSFETs, generally anywhere between sort of 400 and 900.
Okay.
If you see anything like lower than 200, it's generally an issue. 580. 580. 493. That one's different. Ah, that's actually something different. That's a voltage regulator. Okay, cool. Right, so I've just quickly gone ahead and I did this instead of actually because I'm trying to sort of speed things up a little bit. Yeah. So the output section here, the MOSFETs here, we had some short circuits across the rails which we managed to get rid of by locating the FETs which had the issues, which was this one here and this one here. This one had a short circuit from gate to source. This one had a short circuit from drain to source, and we found that out because the gate was showing a different value to the rest of the FETs here. Now, these FETs all show the correct readings on the multimeter. However, it doesn't mean that they are okay. They could still be bad. They could still be leaking, for example. They could still no longer be a FET. They could still just be a diode. And so the way to find that out is to put a tiny bit of power into the amplifier. Excuse me. We want to build the rail voltages just a tiny bit. And so we want to pulse the remote on the amplifier to get the power supply to switch for like a split second. That will build the rail voltages into these capacitors by like a tiny bit. And that will show us like maybe plus or minus 10 volts on the rails. And with the plus or minus 10 volts stored in the capacitors, we can then go along and make sure that the correct voltages are on all of these FETs. And if any of the incorrect voltages are there, then we know that there's an issue still. So I think that's what we're going to do next. But very quickly, before we do that, we're going to make a very brief repair to the wire coming from this transformer. Because as we can see here, this is snapped off, probably from vibration. So what we're going to do is we're going to take a standing knife here. We're going to cut just a little bit of this off here, this insulation, so we've got a bit of bare wire spare. There we go. That's a nice looking healthy bit of wire. I'm going to turn the board over and we're going to suck the solder from, I'm going to let Ashley do this, suck the solder from that hole, so that's that one there. So we're going to turn the soldering on nice and hot because this is a thick trace. So we're going to go up to about 440 degrees on the soldering iron. So take that there. And now this, we want to go underneath the board, probably about there. So I'll let you heat that up. Oh, there we go. Nice. That was done really quickly, nice and easy. See that hole there? So if you have a look at that hole. So that's where the cable's going to go. So we take our soldering and put that down. We're going to leave it turned on because we want to heat the wire up. Flip this back over for a sec. And then we're going to shove the wire through that hole. Like that. And that should poke through the other side. Just like that. And then, yeah, go ahead and solder that in just like you did the FETs. So you want to put a lot of solder on this one. Yeah, okay. Just go ahead and just shove it on. Yeah, go ahead. Yeah, proper loader up. Put a shit ton on there. Go for it.
I think there's that part of me that's like, it's gotta be pretty, and it's like, no, just gotta. caused a bridge.
That's okay. So the bridge is fine. That bridge is fine. Yeah. But what you want to do is you see how this isn't connected to the bit of cable. That needs to be connected to the bit of cable. That's very important. So, oh, that's really weird. It's not actually taking.
No, it's not taking very well.
Okay, let's pull the wire out. Oh, was that hot?
Sorry.
Okay, that's alright. So this is actually copper. By the looks of it. It doesn't look like it's insulated, but just in case it is insulated, what we're going to do is we're going to take our standing knife here. It's really hot, isn't it? Jesus Christ, it gets really hot. Yeah. So we're just going to scrape off, just in case there's any insulation on this cable here. It shouldn't be, because it's actually... Oh no, it will be insulated. Yeah, so the reason the solder wasn't taking, that was my bad, I completely forgot that. It's because this wire has actually got a layer of insulation on it, because it's actually the copper strands that are wound around the transformer. So that's why that wasn't taking. So what we need is we need a little bit of sandpaper, but I'm not sure if I have any on me at this point. Just wait for this to cool down a little bit. And I'm going to get some of these pliers. I'm going to try and separate these 3 bits of wire. No, I think they're all soldered together, so come over. There we go. Okay, so we've separated those 3 bits of wire, and I'm going to take my standing knife, and now this has a really fine layer of insulation on it. You can't barely see it, but you just need to scratch it off like this, all the way around. Because it's like insulated, tiny little layer of lacquer or something that insulates that. So it's going to sort of go around, scratch all that shit off, and then once it's all scratched off, the solder will take to it. Yeah. That's all right. This blade is actually pretty blunt. Yeah, this is a pretty old blade. It's actually sometimes a bit easier and nicer to have a blunt blade, because you can do this sort of thing and it's not too dangerous. Now I usually keep a sharp blade just like separate outside of a case for other things. Yeah, so Greg Fagan is running a really badass system. It's a really nice system. It's some Def Bonts 415s, I think it is, or something, or maybe it's the new ones. But yeah, very badass system. And he's running 3 of the Def Bonts 12K amplifiers, I think they are. Very big very big Korean boards, and it's very fucking loud. It's in the 160s. It's in the mid 160s, 163 decibels or more, which is very loud.
What, your van? What kind of decibel is that? So
my van at the moment, with the small subs and the small amplifier, is 152.8.
Wow. I can't imagine it's like louder. Oh my gosh, 163. Jeez.
Yeah, it's ridiculously much louder. Yeah. And the higher the numbers you go, so like the difference between 120 dBs and 121 dBs, it's like a little bit. But the difference between 155 and 156 is like 4 times there. It's exponential. Yeah, you got it bang on. So we're gonna get the rest of this, get the solder out of that hole there, because that's all in the way now. Okay, there we go. And now hopefully this should now take to the solder, because I have done the scrapey.
Scrapey. Okay.
Yeah, whack it on there, shit ton. Ah, that's better.
Nice,
yeah, go on.
Taken.
That should be enough. No, that's good. Perfect. Yeah, that's perfect. So yeah, we just need to scrape the insulation off there, and that was perfect. Now we maybe just cut that little excess off there. There we go. Okay, perfect. Right. So now comes the slightly scary part.
Uh-oh.
So now is the slightly scary part, because we could have an explosion now.
Oh, that's okey dokes.
Yeah, and the reason why we could have an explosion is because so with the output section, I only found 2 obviously dead FETs. Now, just because I found 2 obviously dead FETs doesn't mean that the others aren't dead as well, but they aren't reading as dead. So if the others are dead, if some of the others are bad, then we could have a FET explosion. So this is just going to be one of those risky things where we see whether it's going to explode or not. Because if these are all fine, there's no point me removing all of these. I can just go ahead and replace the batches. So obviously there was 2 FETs that were bad. We can't just replace the 2 FETs that were bad. We've got to replace all of them in the same bank, which we will work out in a minute. But with those 2 removed, we still have enough FETs in the bank to make the amplifier work. So we should technically be able to apply some power, and if the FETs that remain in the board aren't damaged, then they will come on, switch, and the thing will come to life. So this is the point where we see if it works.
Should we move the alcohol out of the way? Otherwise that's going to cause a fire.
Oh no, it's not that much of an
that
explosion.
much. Okay.
No. This thing will just go pop like that.
Oh, okay.
And, yeah, it's not going to be really bad.
Oh. Okay.
Yeah. So right. So what we're going to do is we're going to turn the camera to this one, so we can see the oscilloscope. We're going to take the pink probe, which is this one here. And we're going to probe some different things on the board as we turn it on. So I'm going to turn the supply on here. So we've got about 9 volts going in there. I'm going to allow a bit of current to pass. So now that we're turning the amplifier on fully, I'm going to probably turn the current to about 2.8 amps is about enough for this this test that we're doing. So these FETs have the 12 volt, or in this case the 9.5 volts, on the middle pin. So if we probe the middle pin, you can see the scope there jump up to the voltage that we're touching. Okay. When we apply the remote, when I push the pedal, that will turn into a square wave. Because you remember the square wave we saw on this one. So the square wave on this one will be small, and this one makes it big. Then the square wave goes through these, which make it really big, and then the really big square wave comes onto these. So let's turn the setting up a little bit on here. You can see the high voltage. So if I now turn the camera to the scope, and we just touch the remote. Oops, we'll change the camera. There we go. So we saw a little square wave start to appear there. So now, if I go around the other FETs on here, the output FETs, I'm going to check the low side and the high side. And the way we do that is we check pins 1, 2, and 3 and make sure the correct voltages are on them. So for the low side FETs, we should have the negative rail on 1 and 3 and nothing on number 2. The high side FETs, we should have nothing on 1 and 3 and the high side on number 2. So it's literally a mirror image of the low side. Low side 1 and 2, sorry, low side 1 and 3 with negative rail, nothing on 2. High side, nothing on 1 and 3 but positive on number 2. And if there's any discrepancies there, then there is a problem. So let's have a look on our scope cam. So we're going to start off with the FETs on this side. So this is obviously the low side. We've got negative rail on 1. We've got negative rail on 2 and negative rail on 3. So that is a problem. If this is the low side, then we should not have anything on pin number 2, but there is. So that, my friends, is a problem. So we can't go ahead and power the amplifier up any further, because if we do, then something might go wrong. Okay, so that is a problem on this bank. So we have one, oh no. Oops, that's my apologies. I have to take that back, because the first transistor that I probed here is actually a voltage regulator. So that's actually meant to have negative rail on all 3 of these. So you see how this number is different to all the rest of them. See, this says D7, sorry, this says D718 on here. Yeah. This is a different FET to all of these, different component. Oh, okay. So this is actually doing something else. So that's my apologies.
That's meant to do that.
Yeah, my apologies on that. That's my bad. So let's start again with this. So we're going to start with the one next to it. Okay, so this is high side. So the high side should, by the looks of things, let's give it more voltage. So the high side should have a nothing on number 1, which it doesn't, positive on number 2, nothing on number 3. That's perfect. Right. So it looks like these are all going to be the same, because these are all in parallel with each other. They're all friends. Yep, they're all friends. Okay, now these ones are going to be the low side. So we should have a negative on 1, nothing on 2. Yeah, that looks good. and negative on 3. That's perfect. So these will all be friends, so they'll all do the same thing. Looks good. Now let's move on to the other side, the opposite side of the board. So we should have high, so we'd have nothing on 1, positive on 2, nothing on 3. That's great. And these are all friends, so these will all have the same. And the negative, so we have negative on 1, nothing on 2, negative 3. That's great, and these are all friends, so again, these will all have the same thing. They're all in parallel. So, looking at things so far, there doesn't appear to be any leakage on the current FETs that are in the board. So, we are safe to go ahead and power the board up a little bit further and see what happens. Now, when we're powering the board up and we're checking the output section, the output switching wave for the output section is going to be on the pin 2 of the low side FET. So if we take our oscilloscope probe here, we want to make sure that we are probing the back of the FET, you know, the back of the FET here, or pin number 2, the middle pin of the low side FET, which is the one with the negative voltage either side on 1 and 3. So if we hold our probe on this FET here, which has the negative voltage on pins 1 and 3, which you can see here, negative voltage on 1 and 3 on the scope there, hold it on the middle pin here, and we're going to apply the remote, and the amp's going to come on fully, and fingers crossed it comes on. We see a square wave and nothing goes bang.
Okay.
Are you ready?
Ready.
Do you want to hold this on there?
Yeah.
Yeah. Okay. Yeah. Cool. Right.
Okay.
So I'm gonna push my foot pedal on the remote, and we're going to see the current draw from the amplifier here on the screen. So let's go. Let's see what happens. Oh, okay. Now that shouldn't have happened. For those of you watching on the YouTube, we saw there was some negative voltage that appeared there on that thing. I don't think that shouldn't have been there. That didn't look good. Okay. It's just, how high is the voltage risen to? Let's check the other one. So the voltage has risen to -9, and what's the positive one? Positive 11. Okay. What I'm going to do is I'm actually going to probe the negative rail here. I'm just going to give a bit more there. Okay, right. So the fact that that jumps to ground is not good. Right. So there's definitely some problem here. So I'm going to go to the scope. We're going to do that one more time. So I'm actually going to probe the negative rail here. So I'm going to probe the gate of the low side FET, and we're going to apply the power and watch on the scope. The rail builds like this, so the caps are charging. Then when the drive circuit enables and starts to drive the FET, suddenly it jumps to 0. So there is a problem there with either the FETs or the drive circuit, because it's jumping to 0, which means it's shorting the caps out. So annoyingly, we are going to have to remove all the FETs because it appears that one or more are bad, or the drive circuit is bad. So we're going to have to remove all these FETs. So, is that something that you want to do this evening, or would you like to do this? So we've pretty much finished the power supply. Would you like to remove all the FETs and see what's going on in the output section, or do you want to leave that for another day?
I'm easy going.
You're easy going.
What do you want to do?
I don't mind. Depends how sleepy you are. It's what is it? It's only about quarter past 12. It's not too bad.
No, I'm good. I'm good to keep going.
You want to keep going? Yeah. Because I think we're not far off. If the drive circuit's safe, all we've got to do, if the drive circuit's fine, all we've got to do is change those output FETs, and then it's fixed.
Oh.
So I don't think we're potentially not far off.
Let's give it a go.
Crazy Logic. Hey, howdy. The new amplifier tech. Yeah, this is the new apprentice here. Absolutely. How many viewers have we got now? Is this going to change? So it's currently saying 63 viewers.
Oh my gosh.
This is not too bad.
It's really good.
We had 82 a while ago.
Did we? Oh
We did.
How many do you normally get?
Yeah, about this, to be fair. About this, yeah.
You have so
Similar
many
numbers to this.
That's amazing.
Alright, so yeah, looks like we're going to be removing all these output FETs then, and going from there. Right, so because some of the output FETs are going to be fine, we don't want to cut them off really. Okay, so before we do that, let's make sure that there's no voltage left on them, because otherwise we'd touch the thing. So yeah, it seems to be there's no voltage, that's fine. Right. So we're going to flip the board over, and what we're going to do is we're going to suck the solder out of the holes of all these
All the
legs.
legs.
So basically we're going to suck the solder out the holes,
Yeah.
so that when all the solder's gone, they're all wobbly. So we just pull
You
them
take
out.
them out.
Yeah, without actually damaging them.
Okay.
David Eskion says, I haven't had much luck with one big box with a lot of subs, but that was because my subs weren't made for it. Just check what is best for him. Yeah, absolutely. Sometimes the subs will struggle with port loading. If your port is to one side, then if your subwoofers have a very soft spider and a very strong magnet, then, well, actually no, a very weak magnet, you may struggle with port loading issues on those subs. So yeah, it's very important to get your box design right.
I feel like this is all like new to me.
It's all completely new.
It's
Yeah,
completely new to me.
you're taking it on really fucking well. The same as with driving. I'm actually teaching Ashley here to drive as well a little bit.
That was
We're going into the car park. She hasn't got a driving license yet, so I was kind of teaching her the basics of the car, clutch control, etc.
Yeah. We're starting with this one, aren't we?
So yes,
That was the fun
they're well remembered. Yeah, starting with that one there. So what we want to do is get this. It might actually be worth doing the same thing we did before,
I'll put a little bit of
where
solder on
we
it.
put some fresh solder on it, which makes it much
Yeah.
easier to suck out.
Oh, it's so this is so like.
It is.
what's the word?
It's really sensitive, isn't it?
Sensitive. That's
really
the word.
sensitive. Yeah.
Okay.
Okay, go ahead and whack it on there. There we go. That's good. And then go ahead and suck that out as you remove it. There we go.
Oh no.
So we want to push this hard onto the board because it's got a silicon tip.
suction.
So you want to make a complete airtight seal. So when you go to suck it, push it hard on the board and then let go.
Okay. So kind of.
You can push this. You can push quite hard. It's not delicate. There we go.
No.
Yeah. No. Nice. Nice.
The thing is like still.
Yeah. No. Look. It's wobbly.
Okay,
See? It's
okay,
come out.
that's
It's perfect.
actually-
She did a fucking great job there. That's exactly what you want to do.
Okay.
Now this one might take a lot longer. Yeah, that's perfect. I was going to say it might take a lot longer to heat up because it's got a thick trace.
Yeah.
So just wait for it to all go watery like that, and then do the exact same thing, nice and quick, sweeping motion, push hard. Okay, you might need to do it a little bit quicker. It looks like there's some solder stuck in there. Look, there's a blockage. Yeah, absolutely. There we go. See, look, all that solder
Oh my, geez,
stuck
there's
in
a
there.
shitload.
Yeah, shit. There's a shitload.
Sorry.
There's a shitload in there.
Of stuff in there.
Ashley said there's a shitload in there. There is.
Okay.
Strictly Amps. What's up, Sam? You have a new partner in amplifier. Yes, I do. We have to start some amplifier classes. Yeah,
No,
maybe.
I honestly think Sam should. He's a great teacher, and I honestly think you should get your parents to do like specials.
Maybe. It could be quite funny.
Oh, that was shockingly bad. No, I think they would love it.
Zeus Martin says, just curious, what happens if you put two different signals on a dual voice coil sub? Well, if the signals are in phase, then it'll work, but one coil will be getting more power than the other. If the signals are not in phase and they're different, then you're going to have massive issues and it's going to sound like shit, and you risk damaging something. How are you grounding your scope probe? It's actually grounded through the mains ground, the mains electrical ground, or did you burn yourself a little
Sorry,
bit?
no, I'm fine.
You sure?
Yeah.
You good?
Yeah, sorry.
It's actually grounded through the mains electrical ground, and it's referenced to my power supply, which is quite handy. It's not the safest way to do things, but it works for me. Got it okay?
I don't know. I think I might need to put some.
Okay, let's have a look.
I'm really bad. I'm not quick like the other thing.
Yeah, this one's not the easiest to get off, is it?
This one's a bit.
There we go. No, it's all in the hole. So if we do the last one there. There we go. So now that's wobbly as hell. So that'll pull out a bit. Careful, it's very hot because you have to wait for that to cool down a little bit. You see the speed that do that with?
You're so fast at it.
Yeah, you just got to literally be super snappy with it. So you got to hold it there ready, and then the motion is like that away, that push off, but it's like a really quick motion.
It just reminded me of yesterday
with the clutch,
the clutch.
So it's like.
I have vision of that kind of girl.
There we go. That's probably now as well. You go?
Okay, yeah.
Sausage Cheese says, hey, I got a Lanza Opti 500.2 amplifier. It goes into protection as soon as I put power to it, but it does not get hot. Ah! Holy fuck! Right. Right. Sausage Cheese. If you've got a newish Lanza 500.2, the amplifier actually might have a design fault. I worked on a Lanza 500.2, 500 times 2, a while ago, and they actually made an error on the PCB design. They actually made a trace issue. On one side, on one channel of the outputs, they actually put part of the NPN gate drive onto the PNP transistors. They really fucked it up, and I had to cut the trace and reroute the drive to the correct transistor. So if you've got a newish board of that, then you need to look into making that modification yourself in order to get the amplifier to work correctly, because otherwise it's going to not work right. It's not going to work right.
Did you tell them that they'd made a big mistake?
Well, no, they're just a Chinese, like, cheapy old... Yeah, they don't give a fuck. I wonder if she knows about that. Crazy Logic's... No. Ashley's my good friend here.
Sorry, knows what?
Well, no, so basically Crazy Logic is saying, I wonder if she knows about that chick with the crazy blonde hair he had in his van a few videos ago. So I think Crazy Logic is assuming that you're going to super jealous about that. But no, Ashley's just my very good friend.
Yeah, exactly. And I have seen the video and it's super awesome. Like how really, her hair is like, whoa, it's amazing. And yeah, no, it's not like that.
Michael Collins says Samantha was her name. So Michael, do you know the girl in in my van video? Because I don't even know her name. I don't even know who she is. Like my friend just came over and was just like, "Oh, sit in his van," and I have no idea who she was.
I love how this is kind of like gossip. It's like
yeah.
Jeez, but like I'm really struggling with this. It's not.
It's easier to flood the 3 legs together on the FETs and pull them out and clear the holes.
Oh.
Yeah, it's easier to do that if you've got a soldering tip big enough, which I do have a soldering tip big enough. No, I've got a really big one down here.
Okay.
But it takes so long to heat up, and it's also misshapen now. Doesn't really. Yeah. See, this was originally a nice line.
Oh, I see.
It's now a curve.
Yeah.
Yeah. I mean, to be fair, Mike James does have a good point. It would be easier to do that. But actually, maybe we'll try that method. Maybe we'll try just to show you different methods of getting these out. I do use that method sometimes, but because I'm quite quick at doing this method, I usually just suck the solder from each hole separately, and it gets done pretty quickly. It's actually quicker for me to suck the solder from the holes using this regular tip is quicker than waiting for the big tip to heat up. Yeah. But with these AC 274 parts, 247 parts, you can't do it. You can't flood the 3 legs with the tip that I've got. My soldering iron's not good enough. It doesn't get hot enough. You have to run backwards and forwards so quickly. It doesn't work. You have to use the big tip here, which is fine. It works, but it's just a bit more headaches. It's easier to learn to do this way.
What's the max heat that your soldering iron can get to?
The maximum heat, supposedly, is 480 degrees. But I don't think this is very accurate. I don't think it actually gets that hot.
Okay.
Michael Collins, I was talking about you, Sam, when you put the wig on. Oh, okay. Okay, yeah. I understand now. Okay, yeah. Very good, very good.
But there is also a video though of your friend.
There is also a video of my friend,
yeah. Her hair like goes like, woo. Sam, I'm gonna ask a favour.
Go on.
I'm stuck at this bit, so if I just...
Well, that's the point. You meant to suck.
No, but I mean like teamwork it. Like I can heat it and you can do the thingy bob.
Well, what do you want to do? Sorry. Which bit am I doing? Am I doing the sucking or am I doing the?
The sucking.
I'm doing the sucking.
Yeah.
Okay, wait.
I think that one's a bit.
Yeah, that's nice and we'll do that. Okay. Right. So if you do that, then teamwork. We're going to teamwork this up.
Yeah, teamwork it.
Oops.
Tell me when. Please.
Wait.
That one's please.
Yeah, okay, yeah, you're holding it. 3, 2, 1. Okay, yeah. 3, 2, 1. Let's just fill that. No, that's not good. Three, two, one. It might be easier just to get this done real quick. Just to do this. Just because the angle I can do it at just works better. What are they saying in the chat?
Just reading the chat. This is funny. Should we just take these out when they're cooled?
Yeah, you could do that. Teamwork.
Teamwork. Good question. How do you try the suckers with heated tips?
Have you tried the suckers with heated tips? Yes, I have. The only sucker I tried with heated tips was very cheap one. So it was very slow to heat up. It didn't get very hot, and it was a bit of a nightmare to use. But I can see the appeal with them. If I had a high quality one that worked and it got really hot and it worked really well, then I could definitely see the appeal. Yeah, it definitely would make life a bit easier. But to be fair, because I've gotten very used to using this sucker is kind of like a heated tip because I can get this in there like that. It's kind of, it would be the same speed. Like using a sucker with a heated tip wouldn't actually make this process any quicker than what I can do with the regular desoldering pump at the moment. Yeah, it's pretty much because I've been using the desoldering pump for so long, I've kind of got the knack with it. So the only thing that would make this any quicker, well, I don't know, I'm not even too sure if anything could make this quicker. A proper desoldering gun maybe might make this quicker, but I don't know, I mean this is pretty quick. Okay, so yeah, Ashley removed all those fits from that side. Nicely done, Ashley.
Thanks, cheers. Yeah.
So we're just going to wiggle all the legs in here, make sure that this has all been removed. Okay, let's have a look. So, okay, some of these I haven't done too well. Oh, whoops. That's not good. Let's leave that there. So that one's removed there nicely. That one's removed nicely. That one's removed nicely. That one is still a little bit attached, so if we just heat that up a tiny bit there whilst we put on it.
This thing I was going to ask, like, no, I guess you have to have that to be able to clear the hole for it. But I was going to say, can you just solder it out? But yeah, you need to have a hole, don't you?
Oh, jeez. Okay, that was being a bitch. Okay, that one's not wobbly at all. Good. Now this one, none of the legs were actually free, so I screwed up big time on that one. Okay, that should be good now. Yep, all apart. Ah, there we go. Okay, perfect. So right, that's all the MOSFETs removed. No. That is the rectifiers. Remember?
Oh,
that's the ones that we don't. That's the ones that are going to be okay. Don't need to touch those ones. So just make sure we have no solder bridges. I'm just going to remove these legs here because these is one of the ones we snapped off earlier.
Okay.
So let's just remove the legs of that one. Yeah, this is one of the ones that we found that was dead earlier. Oops, sorry. There we go. So just make sure there's no solder bridges on any of these. There was a small solder bridge there. That's looking good. There was a small solder bridge there. Just want to double check. Very important that you make sure there's no solder bridges because there's often always at least one solder bridge after you've done some soldering you've got to be aware of.
So yeah, if there was a solder bridge, then it just means it's more likely to be like something's gonna.
Yeah, if there's a solder bridge and you're making a connection where there shouldn't be one, so there's a risk that something's going to explode or get damaged or something. There's one here. Another one here. Okay. Cool. So I think that's all the solder bridges taken care of. Nothing remaining now. Cool. Alright. So, now that we've removed all the FETs, there's no chance of damaging the... There's little chance of damaging the amplifier further because if the output section failed, then it's likely that the FETs that I removed, the ones I removed were obviously dead, but there might have been some others that were also dead but not showing up as obvious. Either that or the drive circuit has problems. So this is the point where we find out whether the drive circuit has problems or whether it was the FETs that actually had problems themselves. I got the hiccups. So let's turn the power. Let's get our scope probe here. Now, actually, what we're going to do is we're going to scope the low side drive, which I believe is this one here. Okay. So this is 1, 2, 3. So the square wave is always going to be number 1. Okay. The same as in the power supply. So we're going to put that in there. And we're going to turn the amplifier on, apply some power. Actually, just whilst we do that, we're going to make sure the power supply is working good, that we fixed earlier. So if we turn that down, we're going to make sure that the power supply that we fixed earlier is looking good. So we're going to check the square waves are all looking nice on the power supply.
Whoa.
Okay, looks interesting.
Okay.
It's drawing some current. Yeesh. Okay.
Oh no.
So the power supply is not too happy because we have some problems. Oh, okay. Something's smoking. Wow. Okay.
I can smell that one.
Yeah, there was some. There's some fucking smoke coming from the board there. Okay. But I don't know where that was coming from. So we're going to take a look with our thermal imager because something would have been getting hot just then.
Yeah.
What the fuck? Okay. Could have been a driver. Okay, this inductor seems kind of hot for some reason. Oh wow! Wait, that seems a bit loose. I wonder if that snapped off the board. That inductor seems a bit loose. I wonder if that snapped off the board, but something was definitely getting a bit smoky over here.
Yeah, something smelled like it was burning.
But I can't tell what it was.
Is it not like...
There's a resistor in here that's pretty hot. Wait, let's have a look. That resistor looks pretty hot. Right, so the power supply was definitely a bit dodgy. There was some pretty bad looking waves over here. For some reason. I'm going to turn the voltage up a tiny bit on here, just in case it was a low voltage issue. Okay, it doesn't look too nice. So we're going to have a look at the output section. Something's getting pretty hot. We've got 4950 degrees. 60 degrees. Okay, yeah, so there's a resistor here. It's smoking. So we've got 124 degrees on this resistor. So I wonder why that is. Now that resistor might be, there's a resistor in the middle of the board here. I'm going to use actually his head cam here. There's a resistor in the middle of the board here, which I think might be to do with DC offset protection. So there might be some DC on these speaker terminals now. And I wonder if that's because of a solder bridge or something. Very interesting. So this amplifier still has quite a few issues. We still have really bad looking drive waves on one of these banks of power supply FETs over here. If you turn your head and look over this one. So these two FETs have a bad wave on them, and we need to find out why. It could be an issue with this transformer, and there is also something really nasty going on the output section. So we're going to take our probe again, and we're just going to apply a little bit of power to the board this time. We're going to have a look at what the rails are doing. So with the FETs out of the board, we should just have a positive rail. Oops. We're doing this one here. You're pressing the wrong pedal. Right, and that one. Right. We should just have positive rail. Positive rail over here. Right, so something is actually sucking the positive rail down to ground. That's very interesting. Now, I'm pretty sure that wasn't happening before. So the negative rail is staying put, but something is sucking the positive rail down to ground. So I wonder what's going on there. So let's take our multimeter and let's have a look and check for short circuits on here. Okay, so it seems to be a short circuit on the high side rail. That's likely to be a solder bridge because I wasn't there before. So I think we still have a solder bridge that we haven't actually taken care of. So I'm going to turn my soldering iron back on and we're going to check for solder bridges. There. I think I saw it, yeah, I think I saw it. I think I saw the solder bridge. So I think that was what the solder bridge. Now, see, that's just proof there that solder bridges can cause smoky results. Because we had a smoking resistor there, it was getting pretty hot.
Do we need to replace that resistor?
No, that resistor is a high power resistor. It can smoke a little bit, it's no big deal. Okay, so that's removed that short circuit there, so that's good. So we should be able to power that back on, and that shouldn't do that anymore. That resistor shouldn't be smoking anymore. So let's hold that for a sec, and let's power the board back on, and we should have the high voltage rail should now stay put, and it shouldn't sink back down. Yeah, there we go. So now if we look on the scope there, the high voltage rail is staying pretty much put. It's getting pulled down slowly by the pull down resistors, so that's ideal. So let's power the board on fully, and let's turn this to full. Okay, yep, looks good. And as you can see there, we have actually got some square waves there riding along the low side drive. Okay, so this is the output section now fully functioning. So we've got some square waves there riding along the low side drive. That looks pretty good. And let's check the other side. Yeah, so the drive circuit seems to be fine. So I reckon that the issue then was that some of the FETs that were in the board were faulty. However, We do still have a problem, I think, with the power supply. Or actually, that could have just been the fact that we had a solder bridge. So let's check the power supply drive waves. Okay, so power supply drive waves, we have 5 volts on there. Okay, the power supply looks pretty much the same shape. Okay, yeah, the power supply looks mostly okay. The waves are the same shape. The drive waves, you've also got to make sure they're the same shape. So let's go ahead and have a look at the drive waves. So we need to pause it on that one. Pause it on that one. Yeah, the drive waves look identical all along here. That's good. Yep. Yep, that looks nice. And the output waves look pretty much the same, slight deviance, but the transformers will be winded slightly different. They won't be winded exactly the same. And if we have a look on the power supply, we're only drawing 1.5 amps, so that's not a bad thing at all. Let's quickly take our thermal imager and just make sure nothing on the board is getting crazy hot, because that's not going to be good if it is getting crazy hot. So let's have a look with our thermal imager. Yeah, it looks like on the output section we've got the driver board heating up to a normal temperature, about 40 degrees. That's very normal. If we move along to the power supply section, we shouldn't have any power supply FETs heating up. Doesn't look like we do. They're all staying nice and cold. Yeah, it looks pretty good. Alright, nice. Good stuff. So, we have the pull-down resistors getting hot, which is very normal. We have the drive circuit getting hot, getting warm, which is normal. So, yeah, that's very, very good. Very normal stuff. So, the fact that we have a good-looking drive wave here on the low-side drive, which is this wave here. Go to our scope view. So on these amplifiers, you will only ever see a drive wave with the FETs removed on the low side drive. Now this wave, I've got my scope set to AC coupling. So this wave actually rides along the negative rail. If we go to this view here, you can see that this actually rides along the negative rail. I wonder if I can. How do I get that to? I don't know how I get that to actually show the wave without it screwing around. Oh, I think I need to turn noise rejection off. Yeah, I don't know how to get that. Ah, wait, almost. There we go. Right, perfect. There we go. So you can see the wave there is actually riding along the low side drive, the low side rail. So the low side wave there rides along the negative rail. And that needs to be a nice, sharp-looking square wave. And that shows that the drive circuit is most likely intact. So we should now be able to go ahead and fit some new output FETs in place on this board. And it should work perfectly fine. They should all just come to life. And the amplifier will be successfully repaired. So we're very, very close to fixing this, I think. I think all we need to do now is put some new FETs on the output section. I think this is going to work.
Okay, cool.
Okay, and then it's good, then we can go to bed.
Okay, nice.
Do you want some more drink or are you done with your drink?
No, do you want some of
Oh, I'm okay. You sure?
Yeah, okay. Okay. Let's put it there. Right.
So, because there's still high voltage stored in these mini battery cap things, so you have to wait for that to disappear. So you can see there's like 34, you can see the number on the screen there going lower and lower, 33, 34, so we have to wait for that voltage to sink down to 0 before we can touch the soldering iron on the board. Now the FETs which this amplifier uses are they're a little bit high voltage really for what we need. We don't really need to use 400 volt parts. We could get away with using 300 volt parts, but I don't think I've got enough 300 volt parts here to work. So I'm going to go ahead and probably just stick with the originals, some 400 volt parts. See what we got.
I have some questions about like the brands.
So let's have a look in the live chat what we've got going on. The problem with the 10s, blah blah. Okay, I think there's just some chat going on in the live chat between the participants. So let's have a look. IRFP 360 LCs. They're not as good as the 24N40Fs.
Well, different that way. It's between, like, why is there, like...
So they're just different models from different manufacturers. So different manufacturers and factories will make different parts, different model number FETs, and some will be better than others. Some will be better at different things and stuff. It's just about finding ones which work well in your circuit, really. So yeah, we're going to use some 24N40F, which is the original parts which this uses. So the bottom number on here, 24N40F, is the part number. The top number is the batch that they were made in the factory, so they're all made together, so all brothers. So we've got to make sure that the top number is all the same.
Marry up.
Yeah, they've got to be married up. So this one is 1H38BR. So we need 1, 2, 3, 4, 5, 6, 7, 8. So we need 16 of those. So 3, 4, 5, 6, 7, 8. So that's one side. 1, 2, 3, 4, 5.
So you have somebody who's giving me money best then. That's really, really kind.
Ah, Toys for Boys sends me $66 because all girls are evil. You reckon? You really think so? Thank you very much for the donation, buddy. That's very, very kind of you. Thank you very much indeed. 1, 2, 3, 4, 5, 6, 7. One more, and then we're good. Hey, there we go. So we have 16 identical matched FETs there, ready for the output section. Let's have a look. So the rail voltage is now sunk down to 1.5 volts, which is a pretty safe value. I think we should be good now to load these up. Yeah, that's a pretty safe number, so we're good to load these up now. So we're going to slot these in the holes, the same as we did with the power supplies, and bend those over so that they sit in roughly the same position as the power supplies did. So yeah, go ahead and get stuck in with that.
Oh, I was going to ask a question. You know, earlier, at the very beginning, you said about how there's the little guy, middle guy, and the big guy.
Yeah.
Where are the little guys?
And so the little guys on this section are all here. So you have 1, 2, 3, 4.
Yeah.
1, 2, 3, 4. These are the middle guys.
Yeah.
And the little guys are these chips here. So you have this chip here and this chip here. They're the baby guys.
Babies.
They pass a signal to these middle guys here. And these middle guys pass a signal to these big guys.
Okay. That's not where to go. Oh, I feel like there's something in this one. There
Is something in the hole?
Yeah, I'm just gonna. There we go.
Oh, nice. Bevis, are DD funny with TS parameters for their mids and highs? They don't generally list them. I don't know why. They just DD don't really list their TS parameters that often. I'm not sure why really. But yeah, DD don't really list them. Any DD woofers that I get in, I will gladly run TS parameter sweeps on them with the DATS V2. So if anyone wants to know TS parameters for DD woofers, if I have one in stock, then I will run a DATS sweep for you and let you know what the TS parameters are. Cool, looking good, Ash. Nice job. Just got to do the same with the other side. So the other side, I'm going to lift the board up just with this screwdriver because the legs aren't going in fully. Just push that down like that. Get that nice in there. Is this as bad as you thought it was going to be?
No.
It's not, is it?
No,
it's
not.
fine.
Like, I was really scared when you were just like, gonna fix it now. Well, I mean, not that like you've done like most of it. It's just like it's nice to actually see and try and actually understand.
Yeah.
which is good.
But you've done most of this one. You've
I
done you've done all the
I
soldering.
still need to. I'm really bad at the sucking up.
Oh, sucking the holes and that. Yeah. That just takes practice. That's just something
You've got to be super speedy at it. Whoa.
It's alright.
It goes.
Okay, so if we tag team this.
Yeah.
Bevis, do you have any of those 2.75 or 3-inch meters laying around? What from Digital Designs? AW3 EX 2.75. Actually, the EX 2.75, they're not actually available. I've been trying to buy them for the last 3 months, but they have not been available yet. As soon as I get them in, I'll run some TS parameters on them for you, because I'm very curious as well to see what they are. The AW3s I do have, but they're in my car, so I can't take them out really to run TS parameter sweeps on them, sadly. Because they're all soldered in. Yeah, sorry about that. So yeah, go ahead and quite a lot on this one. Yeah, chuck a bunch on there.
Yeah.
Yeah. There we go. There we go. There we go. Nicely done. Let's move it fast up. There we go. Yep.
Okay then. Oh, there you go. Should we tell it?
That's right.
I can't fathom like you know, like put my finger on what it smells like soldering. It reminds me of something like
Reminds you of
food,
something.
like a.
Ah, that's interesting. I wonder if it's like some sort of toast or something.
Some
Some sort of bread. Hello to Dan Doria. Good evening, buddy. How's it going, man? You alright? Good to see you on the live stream. We're just actually finishing off this repair here. Fingers crossed this is going to work from here on out.
I hope so.
A bit more. Nice thick on this one, yeah, I do. Yep. Quite a lot on this one, probably need a bit more. Cool. Can we quickly do those ones? Can you do the thing where you hold them up like I was? Yeah. So what? We only need to do one leg, so there you go. Okay. Oh wait. Sorry, it's because it takes ages to dry. Okay, go on, hold it. Okay. alright. These ones. Cool, right. Nice. So that should be all the FETs soldered. So now we just need to cut those legs off. Okay, right, so now, fingers crossed, it was just the FETs that were causing the issues with the output section before. So, we should be able to power this up and it should just work because we tried the drive circuit without the FETs in the board and it seemed to be okay. So I believe that we shouldn't have any problems running this amplifier now on the full output section. So just before we power it up, one last quick test that we always do just before we apply power to brand new FETs. These are, you know, if these FETs all die, that's quite an expensive mistake. So we're gonna take the multimeter, diode beep setting like this. And we're just gonna make sure that the numbers are all looking okay and we've not got any shorts. So we're looking for 580 something on the high side. Yep, this meters in fact. The low side we're looking for also 570 something. So check the other side. 570 something, and on the low side 570 something. Okay, cool. So looking like we're all good. Doesn't look like we've got any solder bridges. Okay, cool. Right, so that's good. Now we can apply some power, and we're going to apply power very slowly to start with, just in case there's a problem. So turn the supplies on. As we can see over here, we have 9.9 volts going in, and we're going to allow 2.9 amps to pass. So let's first of all just quickly probe the low side drive real quick. We're going to have a look at the oscilloscope here. I'm just going to let the voltage build a tiny bit, and we're going to compare the voltages across the board. So we're just going to let a tiny bit of voltage, about 20 volts there. So we're just going to make sure that we have negative, nothing, negative on the low side. Nothing, positive, nothing. Nothing, positive, nothing. And negative, nothing, negative. Yeah, perfect. Alright. So now let's probe the low side drive here. And turn the amplifier on full chat. Oh, okay, so there's still a problem here. So when you can see the switching drive wave just did come to life. Okay, but the negative rail jumps right back down to to ground. So something is shorting out the negative rail. So that's not ideal. Something is there's a problem there with the negative rail. The positive rail seems to be. Let's have a look at the positive rail. Okay, the positive rail also shorts to ground, so there seems to be something that's kicking the rails in the balls, and that could be a snapped inductor, because these inductors are very wobbly. This one, in fact, is very wobbly itself. So what we're going to do is we're going to turn the power off, flip the board over, and we're going to see whether these inductors are actually making continuity or not, to see whether they're snapped. So let's take a look at this. So the inductors here are... that's that one there, so we should have inductor lead 1 and 2 there, which makes continuity on the multimeter. If my multimeter probes will behave. Yep, continuity there, and on this one we also do have continuity. I wonder whether that's just because the board's upside down, so let's flip the board over this way. Ah, it looks like this is actually vibrated to hell. It looks like, yeah, it looks like, so it looks like we've got some blackened stuff in here. So it looks like this inductor actually has some pretty blackened stuff in there. Yeah, that doesn't look too nice at all there. So that's probably the issue. The issue is probably a shorted inductor on this side. What I'm going to do is I'm going to power the board up again, but I'm going to move the inductor around a little bit. We're going to see whether the scope changes in what it's doing when I move the inductor around. Oh yeah, you can almost hear some sparking. Yeah, I don't think the inductors are very healthy on these. Something's not happy there. Because it's making a square wave. If I probe the low side drain, it makes a square wave very briefly, but then it screws around. So I think the inductors are the issue. Now, inductor problems are a very long process to take it off, rewind, etc. So I don't think we're going to be doing that tonight. However, it does seem that we have made very good progress in this amplifier. We fixed the power supply section. That's the square waves look great on the power supply. The output section looks like we just have some final inductor issues on the output section. There was definitely there was continuity there, which there shouldn't have been, between the inductor lead this side. Yeah, there's some short here that shouldn't be beeping. If I zoom in a little bit there, so actually if you look at the inductor, there shouldn't be continuity here, but there is. So that means that there's a short there. That's not good. I'm not happy with that. There's problems with this. I think there's problems with this inductor. So we're gonna have to. This one doesn't feel as wobbly, and it doesn't seem to be as. There's no black points on it. Whereas this side, there's a black wire under here. Yeah, you can see the blackening there, sparking. So I think there's a problem with this inductor. So I think we need to pull that off the board and have a look at that. But that I think will be for another day, because that's quite a long task, and it's getting pretty late over here in the UK. Yeah, what do you reckon? Yeah. Do you want to quickly unsolder? I mean, unsoldering it's pretty quick. We can see the black wire.
Well, yeah, let's show people what it looks
if
like.
If I want to show, if I quickly unsolder it, so you can see what the blackening looks like on the inductor here. So if I just take the soldering iron, turn that on. Now this is quite a thick bit of blob solder, so we're going to have to leave the soldering on here for quite a while to get this to heat up. Well, I say quite a while, probably like 20 seconds or something. Okay, so that's most of the solder gone from there. Just need a little bit more. Yeah, that's now loose in the hole. Let's go do this side now. Has this been interesting?
This has been really good. Yeah,
thank
you so much for showing me. Yeah,
no, it's not been super boring and lame.
No, it's good to learn.
Okay, that should be enough solder removed now that we can just pull the inductor off the board. So let's wait, which one did I do? Yeah, I did the correct one. So we should be able to now get something to pry it off with, maybe. Yep, see that coming off now. There we go. It's a bit of CA glue stuck on there. And also we have the cable tie we can get rid of. Okay, there we go. So the inductor's removed. So the blackening on the inductor, oh yeah, woo!
Whoa.
Woo!
Oh my.
Oh my lord. So that's very, very, very damaged inductor. You can see there that the actual inductor lead there has completely snapped. Wow, that's going to be an interesting repair.
How are you going to repair that?
Well, yeah, that's not ideal in the slightest.
Is that beyond repairable?
Well, what we need to do is we need to rewind this inductor. So we have to buy some new copper wire and rewind it. So we have to buy all this copper wire and rewind it. Yeah, it's going to be not the easiest of tasks. Let's just have a look. Let's see how far back it is. So if we start to unwind this a bit further here and start to, yeah, we're gonna have to unwind this pretty far. Yeah.
Oh my gosh, yeah, it's really.
It's quite far in. But one thing we can do to ensure that it is just this inductor that's caused this problem, we can actually remove both of the inductors here and power the board up. and if the output section doesn't draw any more current after we move both inductors, then it should show up that actually, yeah, this was the only fault here. Yeah.
None of it looks pretty.
It looks pretty bad.
Yeah.
Yeah, it looks pretty bad. That's definitely a rewind job. What I'm going to do is I'm actually going to disconnect the lead from this other inductor because I want to see whether the board powers up without the inductors present. I'm very curious as to see whether it does or not. So if I go ahead and just quickly remove this other inductor. Your streams are fantastic. I learned all sorts today because you were explaining so well. Definitely going to be rewatching some of this. Thank you very much, Lewis. I'm really glad that you were able to learn some stuff from this. It's yeah, it's really useful info, especially if you want to get into repairing your own amplifiers and stuff. Really cool, nice one. I'm glad that you enjoyed. Okay, so that inductor is now technically removed from the board because we're no longer making a connection. So if I now turn the amplifier back on, fingers crossed, I don't know how, I've never powered this style of circuit up without the inductors in the board, so I don't know whether it's going to like it or not. Some amps probably don't like being powered up without the inductors on the board, but I guess we'll find out here. So if I probe the low side drive once more, and we start to power up the amplifier just now. Okay, right, so we have no drive waves. And the fact that we have no drive waves means that this amplifier uses the inductors to complete the feedback loop. So the fact that there's no drive waves here means that, yeah, it does need the inductors to be in the circuit in order to complete the feedback loop. Oh, shit, look at that! Fuck! Okay, so there's multiple problems going on here. Looks like the inductors have been shaken so bad that not only has it shorted to the inductor itself, but also the inductor has rubbed a fucking hole in the board, and it's shorted to the actual rail trace on the board itself. What the fuck? So if we look at the bottom of this inductor, I wonder if there's going to be... So that was the top. So the bottom is going to be down here. I wonder if... You can't see anything.
Can't see it, but I don't think you would see it though.
No, but that would definitely be causing a problem there. That would definitely be causing a short.
Have you seen that before?
Yeah, I've seen that before on Lanzar amps, but not on these amps. So to be fair, this amp probably needs. I mean, I don't know if I trust this inductor either, but this amplifier could probably do with 2 new inductors. I think, yeah, fuck, I'm probably gonna have to rewind both of these. This is not easy because this inductor is made up of the winds of 1, 2, 3, 4, 5, 6, 7 strands. So we're gonna have to combine 7 strands of copper together and make a rewind of this inductor. That's not going to be fun. The rewinding inductors is not my favorite pastime by any means. Let's see how far back this goes. This is not ideal. I didn't envision this to have so many problems with the inductors. This is emissions.
The thing is, because there's so much damage to the wire itself, even if you rewind, like, how are you going to salvage it?
I just have to buy new copper wire.
Yeah, and screw it.
I mean, sometimes with these inductors, you can get away with losing a couple of winds, and the amp still works fine. It doesn't filter quite as well, but the amp still works fine. So if the breakage is very close to the start of the wind, I could get rid of a couple of early winds and it'll work fine. But I've got to get back to there first. I've got to undo all this.
Let me see that way.
That's okay. What is that? Okay, stuck. Yeah, this is not ideal.
If you're gonna get rid of it and get new copper, can you not snap it and then retry, so you don't have loads to go through all the time?
Yeah, I can, but where this copper might be right, I might be able to reuse this.
Okay.
I've done this before where I've pretty much unwound a whole inductor like this.
Yeah.
I mean, that was this one. So this inductor over here that we see here, I unwound this completely, Tessa taped up the core, rewound it together, but it turns out that it still wasn't good. But in other occasions I've done that and it has been good.
Yeah.
So it's a bit of a hit and miss scenario as to whether the inductor is going to be good once you rewound it. And really, to find out whether the inductor is going to be good after I rewound it, I need my transistor tester to be working, but this one broken. So I'm getting a new one tomorrow. So I should be able to use my new ESR tester tomorrow to find out whether the inductance is correct on these or not. I just want to unwind this enough to see that blown point. We're almost there. There we go, so we're almost there now. We've just unwound the bit that's covering up the blown point. Oh no! Bless you.
Thank you.
Bless you, actually.
Sorry, it's hay fever coming back.
Yeah. Right, okay. Right, I think I've unwound enough. I should be able to now pull that one out. Yep, okay, yeah, here we go. So I can now start unwinding it from the other side.
Do you think you're going to have to do the same for this one as well?
I don't know, that one looks kind of okay. It's definitely better seated.
Yeah.
Yeah. Right. It smells like burnt.
Does it?
Yeah.
Nice. Oh, you don't do it.
Yeah, no, I think this one's toast. I might have to try and find a donor board that has a spare inductor on it to use. Like, these inductor issues are massive headaches, especially when it's so fucked like this. Sometimes it's very hard to wind an inductor by hand to original spec, because these are all wound by a machine and they're very tight tolerances, and they get the wind very, very tight, and it's near impossible to get it as tight as the factory did by hand. So sometimes this is a massive problem. You said this van was going in. You said this amp was going in the van. Yeah, Rowan. The plan was to use 2 of these amplifiers. I already have one of these LW Audio 4500s, but the plan was to use 2. But looking at this inductor, I don't know. I'm not sure how feasible that's going to be as to how repairable this is going to be now. Unless I can find a spare inductor from somewhere. It's a bit of annoying. I didn't actually think that this had quite that much damage to it. Yeah, no, this I'm going to have to pull this whole thing off. Yeah, so that's a bit annoying. So we got very far with this amplifier. We repaired the output section, repaired the power supply section, repaired the output section, repaired the power supply drive circuit, and now it's just the output inductor that's left to go. Need to put some Tessa tape and some CA glue on this one, and need to rewind this inductor or something, get these inductors sorted out, and then yeah, just somehow at some point I'll just have to come in here one day, sit here, unwind this whole thing, spend some time on it, rewind it up, and try and get the inductors to match the original one. Fortunately, I think this inductor's probably survived. So because this has survived, I can read the inductance of this one and then build a second one for the other side that matches that inductance perfectly on the specifications.
How did it
Oh, it's probably like a couple of hours. Like, yeah, you got to get it super tight. Yeah. It's just massive missions. Unwinding it's quicker because you're just unwinding it. It's just like you're taking it apart. Putting it back together, you got to wind it really tight. It takes ages. I just want to try and get to that bit of black because I want to see whether it's damaged the core or not. I think we're getting there. Because the core is like what the donut thing's in the middle.
Yeah. This stuff's really cool.
Yeah, all silicony stuff. Yeah.
It reminds me of, remember that? What was it called? That program? Oh no, it was a film with Robin Williams, and it was like Flubber.
Oh, Flubber. Yeah,
It reminds me of
Flubber.
Flubber. Them in the oven and dip them in liquid. Whoa.
Tron 1731, thanks for the advice there, buddy. That's useful.
Yeah, he is a great actor. He's like my favourite.
How's your rum and lemonade? Does it taste
good.
alright?
Sorry, I've been
Does
super
it taste
slow with
alright?
it. Yeah, it does. Do you want some more?
Oh, a little more then. Okay, so we're starting to expose the core now.
Yay.
Just need.
Bless you. Bless you. Bless you.
Excuse me. Almost there, almost getting to the black bit. The black bit seems to be like the bit that's like the longest to take out. Usually these inductors, they get burnt or whatever right at the end of the wire, but this one, no, right in the middle. Very annoying. What would you do if you won $1 million? A lot of things, but I'd probably try and set up my own amplifier company, like designing and building my own amps. I would sort out Henry from Harwood Acoustics. We'd have a big manor house in the countryside. I'd get him to build me beautiful transmission line speakers and floor standards and SQ stuff, because that's what he loves doing, and I'd get him to build them for customers as well. And we wouldn't worry about how long it took. We just have fun with it. Build a massive listening room. Have all sorts of different brands of speakers in there to compare. You know, okay. So that's just what I do in regards to my hobby. Obviously, I do lots of other things as well in my life, but in regards to my hobby that you guys are interested in, that's probably what I do. Right. So here's the core, and yes, looks like the core got a bit blackened as well.
Yeah.
And the cable's snapped for sure, and is shorting out. Right, yep, so there's the core. So yeah, we've got a dent in there, and that's going to be shorting to the core. A dent in there, that's going to be shorting to the core. And the wire itself did snap, where is it? Here.
Yeah, it's pretty bad.
So yeah, that snapped pretty bad there. So I'm probably going to have to go ahead and get some new wire.
Can you use these bits that haven't snapped and then just replace that to one strand of wire to add on?
I could possibly, yeah. But the only issue is that this original strand has got some blackened bits up here somewhere that were shorted. I mean, yeah, it's best just to replace the whole wire.
Yeah, I guess there's no point just change that bit and then it's going to happen all over again.
Yeah, it's best just to replace the whole wire. Very annoying. But it's doable. It's just a bit annoying. Just a bit long to do.
Yeah, that's it.
I just have to. So what I have to do later on in the week, I'm just gonna have to calculate how long wire I need, and then I'll start to wind it. Yeah. But screw that. That can happen another day because that's really long.
When you say you have to calculate how long the wire is, Surely, would you just move
Yeah, so
the
yeah. So I
yeah.
take all this off and like long it out,
Yeah.
measure it, but then times it by 7,
Yeah. Oh, okay.
and then
yeah,
order
gotcha.
7 times that. So then when I get it, I can fold it over 7 times, cut the ends off, so I've got 7 strands worth of that length.
That makes sense.
And
Okey-dokes.
then do it.
Yeah.
Very annoying. I mean, I could possibly test the amp by whacking this in place, but this one's not good. This one's got a fault. I usually have some spare amplifier boards that have some spare inductors on them, but at this point in time I don't think I have any spare inductors that are large enough to cover what this amplifier is going to be putting out. Yeah, pretty annoying, because I'd like to see if this thing was working or not fully. Well, I haven't got an inductor to do that with. Oh well, but I know. Looking at the drive waves, this amplifier, the drive circuit is fine. It hasn't been damaged. So if we replace the inductor, I have no doubt in my mind that this is going to work beautifully. So actually done a brilliant job.
Thanks. Oh no, thanks
Yeah.
for teaching me.
Yeah.
And yeah, it was
So it's
awesome.
almost fully repaired. Just
I
needs a new
know.
inductor. Then we're good.
So close to being done. Oh no, thanks so much for showing me. And let me
That's
have a
right, and I hope that you guys on the stream enjoyed this little video where we're showing somebody who's never repaired an amp before how to do it.
Yeah. Not that I mean, I still, yeah, I'd be, yeah, I need to, you'd have to help me out next time.
Oh yeah, it is always never pick it up straight away, but
Jokes.
that sucks. That is a bad part, but you
Yeah.
can fix it. Yeah, I can fix it.
Yes,
It's just
you can
long.
fix
It's just
it.
a bit long. I have to order some parts. It's just annoying. I like when I checked this amplifier out, I didn't notice the inductor. I was hoping this was going to be like a kind of simple-ish repair. Turned out to be quite relatively involved. Luckily though, this driver board didn't have a problem, because we would have had to take that out and you have to solder new chips on.
Wait, how would we found out that I did have a problem?
So if we took all the FETs out, you know, I checked the square waves.
Yeah.
If the square waves looked really bad,
Right.
then we would have to change these. If we change these and the square waves still look bad, we have to change the chips.
Okay, so it's like following it back.
Yeah,
from,
following it back.
Yeah.
Some amplifiers, these chips drive these directly without any middlemen.
Right.
And that's when we change chips mostly. This amplifier is quite good because these
got the
don't die
middlemen.
often. Yeah, middlemen. But if these chips die, I do have loads of these spent chips. But yeah, you have to use this hot air gun. So you have to like take the board out and then you heat the chip so that all the solder melts. And you take the chip off with tweezers and you put the new chip on and you heat the solder so it melts like this with the hot air gun. Right, yeah. I think we're done for this evening then. I'm going to order some new wire and I'll fix this in my own time. But everyone, big round of applause to Ashley. She did a fucking brilliant job, fantastic job on this repair.
Cheers.
She really took to it really well, and she got the knack of the soldering pretty quick, and she could understand all the drive waves on different parts of the amplifier. So really, really well done to Ashley. And yeah, I think this was pretty interesting video for those of you who are watching that maybe haven't repaired amps before. I guess this was quite a nice, because I kind of described everything quite in a simple manner, so quite useful for you guys if you haven't repaired amps before to see the general process and how it works.
Oh, thank you. Cool.
Yeah, Rowan,
Yeah.
you spelt that perfectly.
That was perfect.
Yeah.
I mean, sometimes even my family members get it wrong, so I mean, that is impressive.
Exactly. Right, so yeah, I think we're going to get some sleep now. It's 1:30 in the morning here in the UK. But thank you very much for joining us on this journey, and I will definitely catch you in the next live stream. Have a good evening, and see you later.